The Earth is very flat.
What's going on, everybody? It is Wednesday, April 7th. This is Brandon, host of Brandon's Show. Hope everybody's doing good out there. Good to be back. Had to take the night off yesterday due to some work constraints, unfortunately. Just that time of year. Hopefully it calms down and I don't miss too many more shows, but it is what it is. And let's see who we got in chat. I'll say hello to start off with. White's Word, who says good morning, good evening, or good night. What's up, White? Almost Unbelievable Ranty, what's going on? Bill G says sound is good. Thank you, Bill. Arwin, Earth LARP Dumpster Fire, page 42, and Data on the Plane. What's up, Data? I read your comment earlier. The fool on the hill sees the sun going down, but it's the eyes in his head that see the world spinning around. Indeed, and if you listen to that song, it's like, holy shit, are they talking about what I think they're talking about? And I wonder sometimes. You gotta wonder about that kind of stuff. But anyway, looks like there's some more. My chat is really refreshing really slow. Let me fix that before we get going. Anyway, if you want to support the show, you can do so through Streamlabs. The address is always at the top of the screen. It's really easy, and it cuts Google out of the middle, so that's much appreciated. But I'll find it later. That's okay. Anyway, we've got some people in Discord. Jeremy, Global Virus Foe, Rob Keen. And we'll go over there in a minute. We're going to talk about the sun today. We kind of started talking about it on Monday, and it seemed to be a popular topic. We haven't talked about it for a long time. So I don't know if there's been any progress made on this whole subsolar noon thing. We could talk about that a little bit. Until I get real world data, I'm not too impressed with that. But it is what it is. And we'll see what everybody else has to say. This is usually a pretty good topic. So let's go. What's up, guys?
What up? What up?
What up? We got Jeremy, Global Virus Foe, Rob on the level. Keen, what's going on? How are you guys doing today?
Doing good.
Good to hear.
How was the Illuminati meeting last night?
Excellent. We decided we're going to push off the Mark of the Beast program for like 6 more months, so everybody can take a couple of deep breaths.
Excellent.
Oof.
Yeah.
Excellent.
Thank you. Thanks for that. Yeah.
It was a close vote. I of course voted to just go ahead and start the reset right now.
Just get it over with, right? Yeah.
Yeah.
I hear you.
I mean, what are we doing here? You know. But yeah. Unfortunately, no. I was working, so it wasn't as exciting as that. But so what's new? What's going on? What's the word around the flat Earth community over the last couple days? Anything exciting going on?
Nothing new. I don't think. I don't know. What, you guys got anything or?
I haven't seen anything.
Nothing.
Yeah, not same old shit, man. Same shit. People aren't liking these concentric circles, you know, that I want to measure out. But
what is the pushback?
I've been debating my coworker all day.
What's the pushback on that you're getting?
Just, you know, a lot of crazy shit. You know, people think the height might matter. You know, if people are telling me like maybe the sun's skipping around and shit, like, you know, we got to follow the sun to make sure it's not skipping around. I don't know. Just a lot of crazy shit.
I think this one worries people because
it does.
It actually, there's a possibility to falsify one model or the other here if you assume that the sun is like a permanent object in a fixed position, not something weird or magical is going on. But like I said, this has been brought up to me multiple times, and I still haven't seen any real world observations of what they're saying happens. You can point to time and date all you want. That is literally based on their model. So you can't point to your model and say, well, this is how it works on our model, therefore our model is correct. You have to give us world empirical data, in my opinion. But we should go out.
Yeah, they're saying even that's not going to do it though. Even if we get the real world data, it's too many variables, and we don't know what this. You know. I don't know.
Who's saying that? Flat earthers?
I mean, yeah, flat earthers are trying. I heard somebody spit almost verbatim, what the shit I tried to use to dismiss this. You know what I mean? We don't know how the sky works. You don't know this. Like everything all these flat earthers are saying to me, I've already thought through in my head and tried to use on the Globers with it, but it just, I don't know.
Yeah. You sound a little worried about this one, Jeremy.
I mean, no, I think it'll tell us something. You know what I'm saying? I don't think the sun's skipping around. I think we would have noticed. We got a lot of people in the tropics, people on boats, planes. Like somebody would have seen the sun skipping around. You know what I mean? If it's like that, if it's the Pac-Man map, then we wouldn't have seen it.
Let me say this, Jeremy. If you look at the 24-hour North Pole, 24-hour sun, and you see that they have a setup where it's rotating at 15 degrees an hour, and you see the sun deviating from the middle, and then the off center, and then back to the middle. So it's not moving. If you get a chance, if you don't know what I'm talking about, go look at any 24-hour Arctic sun. You'll see the sun deviating from the center. It's not moving at a consistent rate, the way they claim.
You sure about that? Are they at the North Pole, at the center of the North Pole?
So you cutting out?
Yeah.
You're cutting out, Brian.
What'd you say?
Hold your can up a little more. Maybe the wire's loose. The string.
Even if it, I mean, it's not skipping a space. Like you can see it the whole time. It's not, you know what I mean? You'd see it like skip forward or backward a little bit. No?
No.
So you're saying the speed's not consistent?
What about those videos where we got the plane following the sun flying from like Los Angeles to Russia and shit? I mean, we never observed the sun skipping around. Right? No one has. I have never heard anyone say that they've seen the sun skipping around or doing any weird shit in the sky. Now, there's been weird phenomena that people have seen, like sundogs, and I've seen some reports, but I personally have never seen the sun do any weird shit. It just goes across the sky.
Yep.
Yeah.
Pretty consistent.
That's it. Now, personally, I believe it's going over a flat plane because that's what it looks like, first of all. And I see it moving. I see the sun moving. I'm not moving. Seems like a natural conclusion to draw. And the only thing that they have in return when you bring that up is, I see the sun move, therefore Earth is flat. You know, some kind of mockery, which fine. If you want to do that, that's just a difference of philosophy and approach, in my opinion.
I mean, have you thought
the
of
pendulum? Right? The pendulum is what they always bring up. The fucking pendulum.
Have you thought about this at all? Like, how could you? Let's pretend we get the numbers that they say is happening. Like, how there's no. I feel like you just couldn't explain it. There's no way to explain that. If it's flat, the outer circle would have to be going faster. It's taking 24 hours each time, so it's not like it's different times and shit.
Yeah, I think it's
I
going
don't know.
faster.
Maybe you could I know, but if we get the times back that they say it is, the speed, if we get the speeds back that they say it is, like what could you say after that?
I don't know. Would that be conclusive for you?
I mean, dude, I'm waiting to hear something good. You're a high-ranked flat earther, so I figured I'd see what you had.
Think about this. Let's say you have a flashlight, right? And you're making like small circles. Like if you change the angle to where you're covering a larger diameter, like, and you don't change the speed, would it still make the circle in the same time?
Say that one more time. I don't think my mind was mentally prepared to have to think.
Hold on. It's happening in the same time. 24 hours, the sun's back.
Right. I get it.
In other words, we'd have to see it at two different places, right? At the same time. It couldn't be just one place because it could be moving around in elliptical fashion and also moving in a circle. So one spot faster or slower would not prove it. You'd have to do something across the so-called globe or the flat plane. You'd have to do two to see. You'd have to do two different spots for each way for it to be conclusive. But yeah, then I'd be pretty much. That'd be a tough one to get out of.
Yeah, but I don't know if it would be conclusive for me. I don't know. There's all this other stuff.
But once again, like I said, the sun. Just go to Antonio Subrats. He pointed it out. You'll see that the sun is not moving at a constant speed, or the camera that's set to rotate 15 degrees an hour is somehow malfunctioning. It's one or the other. So we'd have to prove the sun's speed. That'd be an easy way to prove the sun's speed as far as consistency. Now, if we could prove that it's not consistent in the way I just described, then that test is pointless.
That's true, because one of the assumptions is that the sun is going at the exact same speed. No, because it'd be degrees, right? So let me.
Yeah, but they could
say
not
in the
prove.
top
Here's the thing: they
tropic-
can't claim left to right refraction. Okay, that would
say in the-
destroy their whole entire model if the sun was refracting right to left. Okay, if you're at the North Pole in the center, if you're at the axis, and you have a camera set to move at exactly a 15 degree an hour circle, okay, for the 24-hour Arctic sun, and all of a sudden the sun deviates from this, and you line it up center of the screen, the sun.
Yeah.
If the sun falls out of center, then it's not going exactly 15 degrees an hour.
Well, they don't say it's exactly 15 degrees an hour. It varies.
They also
During
say
the
that the
course of
Tropic
a
of
year.
Capricorn varies, the Tropic of Cancer varies. It's
With the
constantly
moon.
changing.
With the moon, yeah, but the tropic, I think they say the tropic. The point is, the outer circle, the subsolar point of it has to be faster on the outer circle. Like all that other shit with refraction, it's not moving this. If you get the subsolar point speed, I mean, that has to be moving faster at measured locations, or it's slowing down over land where we can measure it and then speeding up over water. I don't know, like how you would.
Well,
you
yeah,
could
let's
even
think
get
of
around
this,
that,
though.
but-
So let's think of this. Why would they make a claim anywhere you look that the Tropic of Cancer and the Tropic of Capricorn is changing locations? So think about that. Let's put our heads to it. So why in the world would they claim that it's changing?
How many
Okay,
degrees did it
it
used
would
to
have
be?
to be
it-
because
right
the
now it's-
subsolar point that they're observing is changing, or the speed. So they're getting they don't have anything consistent, or they're getting
What was
separate
the-
readings and just claiming that it's changing. You know?
What was the previous latitude line? Because now it's like 23 point something. What was it before when they changed it?
That's the $1 million question, and it was something different. And then when they
Well,
go back
has it
next time, it's going to be
changed, or-
something different. It's always
No, I know,
changing. They
has it-
say
What was it before? It's 23.5.
different. I can't tell you because I don't have that information in front of me, but I could tell you
Oh, no.
different. If they say it's constantly changing, that means the time before that it was different. That means every time they observe it, they get something different.
So the latitude
Also, the
of
sun is if the sun is half a degree in size, it's that's a big margin of error. If you're only measuring a few hundred miles, if the sun itself is half a degree, then how long is the shadow? Is there no shadow for? That you'd have to time it out where exactly right when the
Kosho
shadow.
said there's like a 4-minute window
Yeah.
where there's no shadow to having a shadow or something. I think it was like 4
So
minutes.
that's 8 minutes for each shadow. That's a potential 8-minute difference, and that's
That's
massive.
why you want to be measuring this, at intermediate points, like at least hundreds of miles. Australia would be nice. There's places in Africa and India that would be good. Mexico is a good spot for it. There's not a lot of locations for this. If it was in America, we would have had this shit done by now.
right.
But I don't know if we can prove. Okay, so what I think is going to happen, my common sense tells me, is that if we were to get a bunch of subsolar points and everything, time it out, that it's going to be the same everywhere. But that doesn't line up for either model. That does.
I just
throw
want to
you back
figure
to
out
the
what's going
Pac-Man
on.
model, dude.
Why does
Yeah, I
it?
just
Why
wanna
does
figure out-
Why do you say it would be the same everywhere? What leads you to say that?
I don't know. That's just what my common sense. No, that's just my prediction. I think if we did it with the best accuracy we could,
Yeah.
and lined it up, or right when the shadow starts, we hit the timer, and at the other spot, right when the shadow starts, so we get the margin of error down as small as possible. At these different locations, I think the sun's going to be moving pretty much about the same speed. But then again, looking at all these other observations, it's probably going to vary every time you do it. If it varies every time you do it, then nothing's set in stone.
But Brian, you're saying that at different latitudes, it would be the same speed that common sense tells you that it would?
Yeah, in my head, that's what my common sense tells me.
With the sun circling over a flat plane.
That's not thinking about either map or either model. That's just thinking about measuring the speed of the sun, and but it also, my common sense also tells me it's probably gonna. So I'm getting conflicting thoughts in my head, to be honest, man.
Okay.
I'm thinking, it probably varies every time we do it. We'll probably get something different.
Yeah, there'll probably be a margin of error with it, but
Well,
I think
listen,
you would get a.
it needs to be done. That's just the bottom line. So here's my hypothesis. The sun moves at a faster rate in the southern or south of the equator than it
Please
does in
don't make
north of the equator.
hypotheses up.
That's my hypothesis. That's what I predict.
No, please don't make hypotheses up, because then they're going to be.
Hello everyone. I have an idea. Well, I don't know if I call it an idea, but you don't have to even wait till the southern summer, because we know on the 21st of June that there was a 24-hour Antarctic sun at that time of year. So that means that the sun is going around the Tropic of Cancer at that time of year. And if you flatten out,
you mean Arctic? You mean Arctic, bro?
Oh, sorry, the Arctic. Sorry, Brian. Yeah, the Arctic. Around the Arctic at that time of year. So when you flatten out, like you take the Gleason's map or a flattening of an AE map, I'm not stating that they, as I said before, I'm not stating that they are absolutely correct in dimensions or anything like that. I don't know. But if you flatten them out, that makes both the tropics and the equator bigger. So if you could somehow find out in some estimation of what speed the sun is moving on the 21st of June at the Tropic of Cancer, that would definitely, because that will definitely bring you in the right direction. You may not even need to do a whole lot more after that. Because if that matches...
Yeah, I got one more point also, quick.
Hold on. I'm not sure I understood what Brian's point was. So what would we do?
On the 21st of June, if you get the subsolar points on the 21st of June, then on the Tropic of Cancer, then you might be able to determine the speed that it's moving around the Tropic of Cancer. The Tropic of Cancer on a flat plane is bigger than the Tropic of Cancer on the globe. Because the oceans are bigger. The land masses might be the same size, but the oceans are bigger. Even the Tropic of Cancer, including the Tropic of Cancer, the equator, and the Tropic of Capricorn are all bigger in diameter on the flat than they are on the globe. Because the globe's equator, which is its biggest diameter area, is based off of the radius that they don't have. But if you just do it on the 21st of June on the Tropic of Cancer and see if there's some estimation of speed, you can't prove it. You can only estimate it because we don't know what's going on with the sun. We don't know what it is. But if you could show that speed is wrong for what the globe claims, then that would
can prove it.
What
do you mean we can't prove
Cancer is bigger?
Brian, what do you mean we can't prove it? We can measure it.
Well, I don't know.
Yeah, but we don't know that. There's one variable we're forgetting, guys. A very important variable. Okay, if I see an airplane passing by my local sky, okay, and it's going a certain speed, okay, it's low, it's probably about 3 miles high, and it's going about 500 miles an hour. Okay, and then I see one twice as high, going 600 miles an hour. Okay, then they're going to look like they're going the same speed. Okay, so if the sun could be closer during the Tropic of Capricorn, the southern.
Just let me stop you right here, Brian.
Yep.
Brian.
Good.
Distance doesn't matter for this. It could be 1,000,000 trillion miles, or it could be 10,000 miles, or 1 mile. It doesn't matter. The ground speed is the ground speed.
So what about with the airplanes?
However high up this thing is, It's the same thing with airplanes. The ground speed is the ground speed. It's not going to matter how high up a plane is or how low down it is. If you measure the subsolar point, you'll find the ground speed of both the planes, however fast they're going. You won't find their speed.
I see
You'll
what you're
find the
saying.
ground speed. That's why it doesn't matter how fast the sun's going. It doesn't matter the height, what it's made of. If it's a hologram, if it's a mirror.
So
if
as long as
fucking,
it's directly above us, we consider it a physical object just for the sake
you
of
don't
measuring.
even have to. It could be a hologram, a reflection, a mirage, a magnification. It doesn't matter.
Tangible.
No,
It's got a speed. I know. I see what you're saying. Yeah, that's
Not
coming out wrong, but it's got a speed. Whatever the fuck it is, it's got a speed. That's what you're saying.
Yes.
So-
And the subsolar point speed is a measurable. It's something we can know.
Gotcha.
Yeah, because it's the distance between 2 or 3 points. So subsolar point for one person and then 2 other or 3 other people. You can determine with the distance, the land distance, at what rate it's moving around the land. But the problem is we don't know what the sun does. Well, I suppose on the 21st, it depends. If you can get a video as close as possible to the center of the Arctic, the very place another place we can't really go, we don't really know what's in there, and see if the sun changes the way it moves around you in a circle in any way. Because I don't know if it changes its rate over the waters, because it could move at a particular rate over land and change its rate over waters. I don't know what the sun is. That's kind of our problem, isn't it?
It's not really a problem. We don't see for this subsolar point thing. It doesn't matter what the sun is.
Yeah, the speed.
We get this
would-
ground.
speed
We get
would,
this
uh,
ground speed of that,
yeah, but-
whatever it is.
Yeah, but that
And
would be
that's
over
that.
land. The
Yeah,
point I'm
over a
making
known
is you could,
distance, a known land distance. We measure the subsolar points in between 2 known land distances, and we come up with a time.
yeah, but
have the
that's
speed.
over land. My point is we don't know what the sun is. We don't know if it's changing its rate over water. So over land, it might be
Yeah,
going at
yeah.
the speed that would be predicted by the globe, but over water, it may not be.
It
You
could be
understand what I
speeding
mean?
up.
So
Yeah, it could be speeding up
don't
over
know.
the ocean.
Yeah, we don't know what it's doing. But I would say once you do it on the 21st of June, if we can find people to do it on just so all they did was just prove that it is at their subsolar and where their location is. It wouldn't take a whole lot and just estimate it together.
I feel like that's going to be the excuse that the flat earthers use. It could be speeding up over the ocean.
Yeah, but we don't know. It could be like I'd say it's more than likely going to be moving fast, just as fast over the land. But I'm only throwing that in there because we don't know what the sun is, so we don't know what it's doing. We know what it's doing when we can see it, but we don't know what it's doing when we're not able to see it.
I mean, honestly, it could be speeding up over the ocean. We don't know how it's moving or whatever. That could be
Well,
one
I think
of
in
the
my
things.
video, man, I showed that if the sun was moving here, I never made my just most basic of points. If the sun's moving 15 degrees an hour, and your longitudes are 55 miles apart, okay, then that comes out to like 730 miles or 730 miles an hour for a subsolar point, which it's not subsolar there, but just for the sake of discussion, if it was, instead of going by sunrise, the speed should be 700 and around 730, just somewhere in that area, when in reality it's moving over. See, just in 14 degrees, not even an hour, we got 805 miles. So and 15 degrees, and it'd be even faster. So that shows it's not completely lining up with a globe. That's off by like at least 150 miles an hour. That's a good.
Yeah,
bit.
you're not going to tell anything by sunrises and sunsets though, because look at if you were measuring the sunrise or sunset at a black swan site. You know what I mean? How many more minutes would you see it for?
Yeah.
Yeah, that's what they were doing at the other channel. They're sitting there.
What if you're looking at a mountain? You'd have to be in the middle of the ocean, or you'd have to at least have the ocean where the sun is either rising or setting. First of all, second of all, you'd have no idea how many more minutes you'd be seeing the sun for due to the bending of light or whatever they say.
In my opinion, the sun is a focal point, man.
I was just going to say that it doesn't. Whatever happens with the rate of the sun over, let's say this does happen on the 21st of June over the Tropic of Cancer. We do get it. We do get people to take their subsolar point and their distances to all whatever. It doesn't change that like the Earth is still not going to be a globe. It's not a problem for us. It's only a problem for them. Like there is no curve. There is no geometric horizon. There is no radius value.
I mean, well, then we should be getting if that's, we should be getting.
One second.
Sorry, go ahead.
Just want to say, airplanes fly with their noses slightly above horizontal, and they fly it that way all the time for thousands of miles. It's flat. It's just a case of what's happening with the sun. So the point I'm making, sorry for making it kind of long, Jeremy, but the point I'm making is, if it's moving at a different rate than what the globers want it to be, then that's a problem for them.
Hold on,
Somebody's
Brian.
got
Somebody's
a
mean echo.
I don't know who that is, but
Yeah, someone's.
okay, I think you're good now.
Yeah. The point I was making is that it doesn't matter to us because it's flat anyway. It's just a case of what rate the sun is moving at. That's a danger for them, not for us.
Well, that's why I asked
Yeah.
that question. Is let's say that we did clock it at the same speed north or south of the equator as we did north of the equator, and it lined up with their model. What
Then
would
we'd have to check the equator.
conclusion be?
We'd have to check the equator then, because what if it's the same at all three? You see what I'm saying? We can't
Yeah,
just do the two and make assumptions.
You don't have to go that far though. If it doesn't match the Tropic of Cancer, then it won't match anything else.
Bro, if it's concentric circles, they can't be all the same size. What did you say? They'd be all the same size or something? You realize we got the sun making 3 circles on a flat plane, right?
How are you
And all
talking,
these
John?
circles are inside of each other. It's called concentric circles. It's like a bullseye.
I think everybody in their head though considers the sun. It's that maps off a little because due to some kind of elliptical sun rotate. You know, sun. I think everybody had everybody at least considered the fact that the maps probably need to be fine tuned due to an elliptical orbit of the sun. I mean, elliptical rotation, whatever you want to call it.
Well, the sun itself may be making an elliptical orbit, even for just some of the year. I reckon it's
gotta
possible. I reckon that in the southern summer, it might be very likely making an elliptical orbit. That could be happening. If you want to call it an orbit, but it's not strictly like what they define as an orbit. But on the 21st of June, if it can be shown to be moving at a faster rate than the globe would allow it to, then that's a problem for them, big time.
I was just going to say that it moved at the Tropic of Capricorn. I don't know, but in all fairness, this would be my closing statements on this. I agree with you. My closing statements. Okay, if we're going to be fair about this, it would be damning to certain models. Okay, but we got to do 2 points at the Tropic of Cancer, like antipodal, whatever model you're using across the flat Earth or across the globe. We got to do 2 at the Tropic of Cancer, 2 across from each other, 2 at the Tropic of Capricorn across from each other, and 2 at the equator across from each other. If in all fairness, and then I will accept whatever the results are. I will accept if we get 2 across from each other at each spot.
We might measure it to be in our favor. I mean, who knows? The results aren't in yet, so.
I don't think it's going to line up with either model, man. In my opinion, the more I think about it, I don't know. So I've pretty much covered every opinion, right?
Pretty much.
It's going to be constant. It's going to not agree with nothing. It's hard to say, man. But in all fairness, if we're going to accept the results, it's got to be 2. Do y'all see what I'm saying, though? Because if
we need
across the
multiple
globe or
points.
across the flat Earth, if it is like an elliptical type of rotating ellipse, then it's just moving further on that side and not the other side. You see what I'm saying? In other words, the whole sun.
We need multiple points, yes. Multiple points.
Yeah, the whole sun is moving inward or outward at an elliptical fashion, not a circle. So.
Break the yachts out. We might have to break the yachts out. We might have to go out in the open seas.
Yeah, the sun might change its movement in the sky slightly, move slightly faster or slower throughout even a 24-hour period if it's making an elliptical. You know, if you want to see it that way, maybe. I don't know. But
man, I did a video called Heavenly Perspective about a week ago, and it shows the sun going down. It's showing the analemma and everything, but it shows the sun going down just in one day. Okay, and it shows it start to go toward the horizon, and it starts to during the winter, the northern hemisphere winter, and it shows the sun start to veer off
You
the
gotta go
right,
poopy in the potty?
as if the sun knows the Earth is curving. What could possibly cause the sun to
You gotta go
be
poopy in the
going
Jeremy,
potty?
your
straight down and
mic's
start?
open.
Oh, all right.
What would cause the sun, in their model? What would cause the sun to start veering off to the right? And it should just go down at whatever angle or whatever degrees. Like say if it's a 23-degree tilt, then it should just follow that line. What's causing it to go down and veer over at the same time? Like it's like the sun knows that it's supposed to be following some kind of curvature. And I mean, I ain't got a good explanation for that ever.
That would be just perspective from your location. If you like, that's how they work on the globe.
Yeah, that's
Depending
my
on your
answer.
location.
Perspective, right? Perspective. They're not. That wouldn't work on a globe. It would have to be perspective, which they don't consider with the heavenly bodies. But that's kind of forcing them to accept that perspective functions. Same thing with the Orion when it's on the horizon during the summer in the northern hemisphere. When it's lower to the horizon, it makes small arcs. Okay, not like it does over the sky. It's making so perspective is showing that to make little small arcs over the horizon, way off in the distance. And that has to do with perspective, but they don't consider perspective in their model.
No, because it's
Well,
so far
they-
away, right? So
Yeah, but even above it, it goes a little bit above the 20-degree, and then it comes back down. It's a smaller circle. Was my point? Smaller arc.
is this what you're talking about? Oh, let me share my screen. 1 second. Okay, that'll work. Okay, is this what you're talking about? Why does it go at an angle like that? Do you see that, Brian? No? Are you there?
No. This is a video. The one I'm referring to shows it going just down at an angle.
That's what this one's
not
doing right
quite
here, isn't it?
Yeah, but this is coming almost straight down.
Oh, more like this?
If you go to Heavenly Perspective on Flat Earth Test Channel, you don't got to play the volume. But if you go toward the end, it's only like a 3 or 4 minute video. But if you go like 3 minutes into the video, you'll see a time lapse of the sun going almost straight down, not quite straight down, but almost straight down, but still angling off to the right.
Yeah, no, I gotcha. I'm just looking at all these different patterns here. I mean, to me, it just looks like, when I look at these patterns, it looks like the sun moving above us, moving around. It certainly doesn't look like it's 93 million miles away.
Yeah, to me, when it's overhead, it looks like it's kind of arcing, but off the distance, it looks like it's going away from us.
Right. Here's some more. I mean, there's all kinds of these pictures. I've got some really good videos of time-lapse sun too that I'll get out.
I mean, we should just do it, get what numbers we get, and then if it needs further examination, we break Brian, you could break your leaky motorboat out, your rowboat or whatever you got, and we'll get out there in the open ocean, and we'll have to just check it there. We'll check it everywhere,
That would definitely be worth doing a fundraiser, like a GoFundMe. You know what I'm saying? And whoever's got.
We're not doing no GoFundMes, bro. We ain't doing no GoFundMes.
One of the ones to go. Get a few people to go, and just consider it a vacation plus an experiment all at the same time.
No, we just need people in certain locations to go out and do an observation.
Yeah.
Whoever's at that location, we'll just find people at the location.
I'll tell you what, right now I need motherfuckers' latitudes. I got like 5 latitudes. I think they're all ballers. We got no flat earth people in between the tropics.
I'm sure.
What's going on, guys?
I'm sure we do.
And you asked Jose if he was in the tropics, because Puerto Rico seems like a tropical climate, but I think it's off the coast of South Carolina, so it's not in the tropics. I don't believe.
Puerto Rico?
What?
Well,
Yeah,
please
Puerto
tell
Rico.
me you were joking just now.
I mean, that's what I just seen on the map. Puerto Rico is like about a few hundred miles off the coast of South Carolina, right?
Nah. I would have used Florida or something.
Yeah, South Florida. I think the Tropic of Cancer. Well, it varies according to them, but I think it's like right down by Key by like South Miami, I believe. I'll double check that.
It's even lower. I think the only place you can even be in the tropics in America is in Hawaii. I'm not sure, 100% sure on that, but
So somebody organized this because are you organizing it, Jeremy? Are you looking for volunteers or?
yeah, we're doing it. Give me the fucking DM me the latitudes. I have in our DMs. I got 5 or 6 latitudes pinned, right?
And you're looking for people where?
Anyone in between the tropics.
Anywhere in between the tropics. So 23.4 north to 23.4 south, I think.
Yeah, that sounds good. We'll go with that.
All right. So if you're
Even if
between
you're
the
out.
tropics, hit Jeremy
Hold on.
up on Discord. Come on into the Discord. The link's in the description. Let him know where your location is because he's going to try to set up some observations of this.
Hey, I'm in
I need your
Wisconsin. Will
country-
that work?
Hold on a second. I need your country. Hold on, Bob. I need your country, your latitude, and that's all I need. But you could also be out of the zone a little bit if you're willing to just like, travel a few miles because there's a lot of
Dude, I
people in
just
Australia like
looked
that.
at I just checked on Google, and it's
Did you find
Yes,
Puerto
at,
Rico
uh,
off the coast
at
of South?
25 degrees.
You're cutting out,
Cutting
Brian.
out, Brian.
You're cutting out.
Did you find Puerto
Okay,
Rico
hold on.
off the coast of South Carolina? I'm gonna roast him on that for a minute. Sorry.
No, he's cutting out.
Could I throw something else in there when you're ready?
What's that?
Yeah,
Brian?
go ahead, Brian.
I just want to throw something else in there
Yeah, go for it.
to do with the Annalena. A lot of people don't realise it, and I didn't get a chance to say it the last night. The solstice in December and in December 21st and June 21st. Around that time, the sun doesn't change its position. It basically is in the same position. I think it's a couple of days or something like that. So it stops changing, like it stops moving. Let's say in December, it stops going south, and it just stops in the sky. It holds the same position. Well, obviously it doesn't stay for 24 hours, but I'm saying it doesn't change its position. It holds that exact position for a couple of days or something, and then it moves again, or something like that. I think it's 3 days or something like that. Yeah, and the same in June 21st. How does that work on the globe?
I don't know. I'm just going to be straight up. The sun is not 93 million fucking miles away. It's just not.
Exactly.
Just fucking look
Here,
at
here.
it. Look at all the
Obviously it's
pictures
not.
of
Who
it.
said
Go
it
watch
was?
videos of it. It's moving across the
Feel it.
sky. It's not 93 million miles away.
If you lived in Florida during the summer, you would feel that son of a bitch is like a magnifying glass. It's got to be a focal point. When it comes up,
Brandon,
you
it's
feel it.
my bad. Go ahead, Brian.
I want to say that in Miami, okay, it's 25 something, okay. Wait, in Key West, it's 24.5. That's the southernmost point in Florida. Is 24.5.
They're just out.
God dang it!
They're just out of range. You could get a boat if you're in Key West, and you got a boat.
Yeah, but let me tell you the problem, Jeremy. The problem is in Cuba, it says there's a sign at the bottom of Key West. It says 90 miles to Cuba. Okay, I almost made it to Cuba on accident the first time I went down to Key West in a boat that we rented when I was like 18 or 19. We went to ask for directions about the reef, and the guy started answering in Spanish. We're like, holy shit. So we almost made it to Cuba. Point is Cuba says 24.5. Okay, so that's 1.5 degrees. That would have to be about 105, 110 miles south of the Tropic of Cancer, and then Key West is a degree and a half, which is about 105 miles higher than the Tropic of Cancer. So that don't make sense, man. I mean, it almost does, but I don't know, maybe. Yeah, we'd have to get a boat, bro, to do it in unless.
Let's just see what we get. Let's just see the speeds we get over land first before we start renting yachts and shit.
No shit.
You have what's his name from Argentina. He would be able to organize something. There's some Globebusters.
Oh,
That's too far south, man.
That reminds me. Whoa,
Yeah, but
Brian, your fucking mic kicked
He can
in
speak
there.
Spanish.
What? Oh shit. Rodrigo Ferrari Nunez from Globebusters. He has a show on YouTube as well. He's an anthropologist. If in case anybody hasn't ever watched him, it's really good show. I mean, he does a lot of analysis, a lot of firsthand analysis. It happens to be come on like towards the end of our show sometimes. So
What's the name of it? What's the name of it again, Brandon?
Rodrigo Ferrari Nunez. I'll find the link in a minute. But
oh yeah, he's a PhD, PhD flat earther.
He is a doctor, of anthropology, I believe, and so he's a doctor. I think he says he's a flat earther. I'm not sure. I don't remember.
Neuroperatodos.
Yeah, no. That's what's his name? Iru Landucci.
Oh, that's Iru Landucci. Never mind. Yeah, you're right.
Yeah, no, his channel I think is called Rodrigo Ferrari Nunez, if I remember correctly. But I'll find it. But anyway, he's gonna come on. We're gonna do like a show. He was hitting me up yesterday, so I'll set that up. But he's down there. Yeah, I think he's in South America, Brazil, maybe.
Something. I mean, maybe you got
Argentina's too low, Brian. Argentina's is too.
There's a very small section of land when it comes to this between the tropic shit.
Right.
Like very small.
Right.
The reason I said Iru Landucci is because he can speak Spanish. I don't know if any of you can speak Spanish, but if he can't speak Spanish, it might be difficult to organise people who are close to the Tropic of Cancer in South America. Whereas
we definitely
speak Spanish.
Yeah.
So that's why I know he's in Argentina, which is too low.
We definitely need to get the essays in on this with us.
¿Cuál es tu latitud?
You think it'd be big? You think we'd have more options, man? It's 1,400 miles from the equator to a little bit over 1,400 miles from the equator to the Capricorn, and a little over 1,400 miles from the equator to Cancer. That's like almost it's basically about 3,000 miles. You'd think we'd have more freaking options, man.
Brian, after we figure out the subsolar point thing, we're gonna figure out how you got your mic so loud. That's right. That's next, right after subsolar point.
How did that happen, Brian?
That was crazy.
What do you do with your microphone? I don't understand. Just giving you shit, Brian.
But spends 3.5 years being too quiet, and then suddenly he's blowing people's ears out.
I know. He has this special trick to make it sound good too, and I don't know why he doesn't do it all. Why don't you do that all the time, Brian?
Tell me which one's the best, guys. This is me with headphones, okay?
Sucks.
All right.
This is me with no headphones but a speaker phone.
Say something else. It was switching over.
This is me with no speaker, just the phone, having to hold it up to my ear. Is that the best?
Wait, did you do all three already?
Yeah, this is me with the phone, no speaker, no headphones. Okay, this here.
That's good right there.
Don't even do that.
Okay, now this is me with no headphones, but the speaker with the phone on speaker.
That's pretty good too.
That one's good too.
Yeah.
So what's this one?
Yeah, do that one. That's fine.
Okay.
No, do the first one.
Yeah, it seems like basically your headphones suck, dude.
You have the worst headphones in the world, Brian.
Wait, I want to hear the third option.
Yeah, okay, that'll be the headphones. The third option is the headphones option, and that's
guys.
This one here.
Guys, go cop yourself a pair of AirPods and a fucking iPhone. I mean, that's what.
Yo, how much is Apple paying you, bro?
If someone's getting paid to hawk shit on here, I want to fucking know about it because I ain't getting anything. Hey,
change your name to Paid Apple Shill.
Paid Apple. That'd be awesome.
That would be pretty
Apple
cool.
Shill. That is hilarious. Hey, did anybody see my most recent not my one I just put out today, but yesterday with my gradient, my pressure gradient in a container?
No, but
So-
we'll talk about it later. I don't want to change the subject
Yep,
to pressure gradient.
Okay. Yeah, that's why I brought it up. Okay.
Okay, we will
Nobody
talk about
watches
it.
your channel, Brian.
Yo, if you're trying to recruit people, in Spanish and Portuguese, latitude is latitude and country is país.
That's a huge help. Thanks, percentage.
That'll
Hey,
come
Brandon,
in handy.
I have another little interesting thing when you guys are ready.
I want to say something first. Tony V, $5. Thanks, Tony. Shout out. Brian, get your face away from the mic, please. But you don't have to change anything now. That was a previous situation. You sound good now, Brian. But
Roger that.
all right. Thanks, Tony. All right, cool. Who wanted to talk? Go for it.
Bob Dole found another little interesting story in this news feed thing. This is good stuff.
Okay.
So this is from CBS News right here. Okay, NASA measures direct evidence humans are causing climate change. Now, that sounds promising, right?
Yeah.
Direct evidence. They measure direct evidence, guys. Okay.
Okay, go.
So let's get into this. Let's get into this direct evidence that's been measured.
Yeah, what is it?
Let's see here. In a first-of-its-kind study, NASA has calculated the individual driving forces of recent climate change through direct satellite observations. And
Already flag on the play with calculated.
For decades, greenhouse gases and suspended pollution particles in the atmosphere called aerosols from burning fossil fuels, blah, 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 blah. In other words, NASA
insert
has
indoctrination.
Hold on. In other words, NASA has proven what is driving climate change through direct observations, again, through their satellites, a gold standard in scientific research. Now, wait, what? A gold standard in scientific research? Direct observations are a gold standard in scientific research.
Yeah, that's fucked.
When
you say gold
when you're doing-
standard, it's something definitive. The gold standard. You don't say a gold standard.
It is the gold standard, the only one, and they didn't even do that one because they said they did calculations based on what they saw through their satellites.
This is top notch, guys.
Propaganda.
What do you want?
That made me
This
want
is
to
the
throw my
best
computer
pseudo-
on the ground.
These are the best pseudoscientists in the fucking world. All right, how dare you?
The funny part is, or the sad part is, that 95% of the population fall for this bullshit.
I'm so fucking tired of the propaganda.
Hook,
Yeah,
line,
they
and sinker.
consider like
I'm going to throw
science.
a link in the general chat there. You guys can go click on that if you want to and read the stupidity. It's so bad.
Thanks for that, Bob. So anyway, about that sun. I'm sharing a video on my screen here. We don't have to talk about the sun all night, by the way. But if anybody has anything to bring up, I want you guys just to watch this, okay? Watch the sun. Look at that. Does that fucking look like it's 93 million miles away? I just don't know how anybody can look at that shit and think that's 93 million miles away. Do you know how fucking far that is?
Why not?
What do you mean, why not? Just look at it.
Remotely compare it to.
Yeah, okay, and?
Look! I don't care. Look! Just look at it.
Yeah,
It's the same size as the moon.
It's right there. It's going over the earth.
Here's the thing, guys.
Yo, listen, if the sun is so super fucking hot and it's so far away, but all of the heat isn't getting lost because there's this, like, this 93 million miles is a very, very, very low vacuum, right? Very, 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 1 times 10 to negative 17 torr, right? If you rise up above the atmosphere, it should be super fucking hot because it's not being diluted by the atmosphere anymore. I mean,
Yeah, they try and use
What?
gases. They try and use gas molecules so spread out why it ain't hot. That doesn't matter. I'm not a gas molecule. If I'm up there, I should be experiencing the sun without all the atmospheric blockage. I should burn up in a flame.
yeah,
I
what's the
should
temperature of the sun?
Very, very hot. I know
If
that.
you can't take me 90
And if you're not
million miles,
losing
That's not how
then
things
you get into
work.
space, these astronauts should be fucking melting.
Right. If that's how it works, then we should be at what's the almost absolute zero at night. But we're not, because that's not how things
No, that's not
work.
true
right?
because there's thermal
Yes,
mass
that
that
is.
absorbs heat. There's the atmosphere
you-
absorbs heat. So what are you talking about?
Yeah,
Yeah, let me-
exactly. So why the hell should you
I'm saying you
burn up
rise above
in
the
there?
atmosphere. And
Why should you burn
the
up
heat
if
has-
there's no atmosphere then?
listen, bro. If you rise,
yeah,
I'm not
listen,
saying if
bro,
there's
you're
no
not making
atmosphere.
sense.
No,
that
I
it?
am
Who
making
is
sense.
that?
You're
No,
just
you're
not
making
listening.
zero sense.
Is that Chikey?
I'm not saying if there's no atmosphere and you stay at the level of the Earth. I'm saying you rise above the atmosphere. It exists, but you rise above it, like these astronauts in space, right?
Right.
The atmosphere hasn't absorbed any of the heat. It's going straight, like full, same temperature as from the sun, right? Because it's not being lost in transit because it's a vacuum. 1 times 10 to the negative 17 torr. There's no atmosphere to absorb it, or relatively none, right? So how come these people out in space and these satellites and everything like above the atmosphere or the majority of the atmosphere aren't fucking melting?
Brian,
You
mute-
just
mute
answered your own
mute.
question.
You're getting feedback.
I can
from
give
your
another
mic.
example of that. Man. Is like think of like if you got a steel plate in a bell jar, okay, and it's airtight, and you shine a laser at it, it's going to heat up, okay, and then if you create a vacuum the best you can in that bell jar, and you shine a laser at that steel plate, it's still going to heat up, okay. Maybe the air might not. The air don't heat up. It doesn't seem to in the vacuum, but the steel plate is still going to heat up.
Radiation.
Or is it? So the same thing with the sun. If I, like I said, I'm not a gas molecule. So if I'm up there, or anything solid for that matter, is up there, it should get hot.
So they wear suits. If last time I checked, they're not naked or something, or in their swimsuit. So.
And those suits can withstand the temperature of the sun?
Yeah, what about the weather balloons? Look at the weather balloons when we get up in the black past the blue haze.
From the sun.
Why don't they melt?
It's not the sun, because the sun is not on top of them. So what are you even saying?
Again, the heat wouldn't be lost.
Now again, if you're sitting next to a fire, you're not feeling the fire. You're feeling heat coming from
the fire
it.
is an atmosphere. It dissipates.
But
due to the atmosphere.
listen, percentage. You just played yourself. Because if you're sitting next to a fire, you're not instantly burning up, because you only feel a portion of the heat. Same with the sun.
No, not the same at all.
Yes,
Because
same with
the
the
sun is traveling through no atmosphere.
But it's the same
right?
with the sun. You're not getting all the radiation coming from the sun at once. It's only a tiny percentage of it, because you're not that large. Problem solved. Done.
You're not making sense, bro.
Yeah, I'm actually making full sense. But
no, you're really
no, he's
aren't,
double
because
speaking.
The sun
Ed is double speaking. He doesn't even realize
it.
At all.
Brian, go sit next to a fire. Do you feel all the heat of the fire?
What percentage handle this?
Yo,
what
listen.
percentage handle this?
The sun's shooting out rays, right? At this super fucking hot temperature.
You're not responding to what I said.
I am responding. You said fire in atmosphere.
You're ignoring what I said.
Hold up. The heat from the fire in the atmosphere is dissipating into the atmosphere around it before it touches you.
What did I say about the fire percentage?
You said you don't feel all the heat because there's atmosphere, obviously. But that's a false analogy, because with the sun, there's not atmosphere.
Didn't mention atmosphere. You only feel a portion of the heat of the fire.
Course, and that's the same with the sun too.
You don't feel all the heat of the fire at once.
Did I say you feel
because
all
you're
the
not
heat
catching
of
all the heat of the fire at once.
Okay, you're
same with the sun. Same with the sun. You're only catching a very small, tiny fraction of the radiation coming from the sun.
Fantastic. Okay, time to let him respond. Right. Let him respond now, Ed.
Right.
Ed let him respond.
The small fraction of the sun. The small fraction of the sun. What temperature is that small fraction when it's leaving the sun?
Irrelevant.
Ed, you want to have the sun. You want to compare it to fire.
That are traveling and hitting you are going to be radiating you and heating you up, right? We're not talking about the entirety of all the rays of the sun. We're talking about the temperature, the quality, not the quantity. So you got to
talking about the tiny fraction of the radiation coming.
Quit comparing the sun to fire.
What
Compare it to
temperature
light.
Are those rays of light dissipating in that vacuum?
Irrelevant.
Exactly.
It's a tiny fraction of the radiation you're receiving, because you're just a small surface. So you can't capture many radiation at once.
Okay, so how about this small surface? So it doesn't matter because it's still covering your entire body, right? So how about you stand in like this room where you're getting pelted at with a laser, even half the temperature, a quarter, probably even like a tenth of the temperature of the sun, and we'll see what happens to you.
Yeah, I told you they wear.
And that's
suits.
with atmosphere.
They wear
dissipating
suits,
some of the heat.
But they wear suits again.
Yeah, so the suit is able to withstand the temperature of the sun. Fantastic.
No. You're
if you agree to this
misunderstanding again, because it's only a fraction of the radiation of the sun. So don't be dishonest now.
All the fractions have the same temperature.
Then don't say the radiation or the temperature of the sun.
No, the temperature of the sun, because all rays of the sun.
That's what you said, percentage.
Bro,
so
the rays of the sun all have the same temperature.
But you're being dishonest when you
and
say
you're fully
good temperature.
covered.
But you're
No,
being
you're
dishonest.
being dishonest because you're trying to gloss over the.
When you
Oh,
say
man.
the temperature of the sun.
It is the temperature of the sun because all the rays have one temperature.
Because you're only receiving a tiny fraction of the radiation coming from the sun. So
Listen.
it's not the temperature of the sun. So stop saying that dishonest
Listen,
statement.
bro. If you have a fire,
you listen, bro.
Listen.
You're being dishonest.
You have a fire
stop doing
and it's
that because
perfectly
I caught
symmetrical,
you,
okay?
and you're
Let's say
trying
you
to
have
get away with it, and it's not working.
You keep rumpusing. Let's say you have a fire, perfectly symmetrical, okay, and it's in an atmosphere that's perfectly isotropic.
You're reaching.
The temperature of anywhere around that fire is going to be the same. Just like the temperature of any sun rays, rays of light that come from the sun are going to be the same. Now you keep on saying the temperature is irrelevant.
No, you keep reaching and you
keep
being dishonest by saying the temperature of the sun when it's
What's
only
the temperature of the rays
when
of
it's
the
only
light
a
that
tiny
exit the
fraction
sun?
of the radiation of the sun, and not
Doesn't matter. We're not talking about the totality
not the
of
temperature of
radiation.
the sun percentage. It's not the temperature of the sun.
Wow. What's the temperature of the sun, bro?
Wow.
What's the temperature of the sun? Why are you scared?
Yeah, why are you ignoring the facts? Why are
What
you
is the
being
temperature of the
dishonest
sun?
on purpose?
Why are you scared?
Why do you keep saying the temperature of the sun?
Yeah, what's the
when
temperature of the
it's only
sun?
a tiny fraction of the radiation you're receiving.
What is the temperature of the sun?
But it's only a tiny fraction, so it's irrelevant.
It doesn't. No, it's irrelevant that it's a tiny fraction because that tiny
it is
fraction.
irrelevant. I'm glad you agree. Finally,
that tiny fraction is covering you entirely. Your entirety is covered by that tiny fraction
of the radiation coming from the sun.
So what's the temperature of that tiny fraction?
So it's not the temperature of the sun.
What's the temperature of that tiny fraction that's covering you in entirety?
I don't know. Look it up.
Exactly. Even if you did know, you wouldn't
exactly. Well, then give me the answers, smart mouth.
Even if you did know, you wouldn't
give
say
me the
it.
answer,
The point is
percentage.
the temperature.
Give me the answer. Come on. Come on, percentage. You said it would be impossible, so give me the answer.
The temperature is the temperature.
You said it would be impossible, so
I'm telling you.
Wait till he's done talking and then respond because it's crazy.
All right.
Yeah, he's not giving me the temperature. He said it would be impossible. So what is the temperature then, percentage?
The temperature is the temperature.
Hold on, wait till he's done.
What's
Wait till he's done.
The temperature. Again, listen.
Yeah, that's a number. That's a number, percentage. Say the number.
The temperature is the temperature of the surface of the sun.
Yeah, and what's that number?
Because there's no dissipation. Because there's no atmosphere.
Percentage.
There's no atmosphere because according to your model, the distance in between is a vacuum of 1 times 10 to the negative 17 torr.
Not giving me the
so
number,
any dissipation is negligible because the atmosphere is negligible. The pressure is negligible, so it would be the temperature of the surface of the sun.
This meaningless percentage.
Hold on, Ed. I'm about to mute you if you keep this up, bro. Stop rumpusing him.
Yeah, he's not giving the temperature. So
you're not letting him talk.
He's not giving me the number.
My model.
How hard is it to give a number? Just say the number.
It's your claim, bro. It's your model. You're the one that contends.
He asked you the temperature of the sun. You're not giving him a temperature either. You lying sack of shit.
Possible. Give me the temperature number now.
Do you want me to give you your model's number because you're too lazy to Google it?
You said it's impossible, so you must know. Tell me.
According to your model, it's impossible. Because
so what temperature then
would not lose. It's like the radiation would be negligible.
Number? Come on.
Yeah, it's fine, man.
Yeah, so you don't know. So you're telling me it's impossible, but you don't even know why.
No, it's cool.
So you're just making it up.
The listeners understand the point.
Let me ask a couple. Hold on. Let me ask a few questions. If you're standing 10 feet away from a fire. If you're standing 10 feet away from a fire, why are you not as hot as if you go 1 foot away from the fire? Because the heat is radiating in the air, dissipating? Let's pretend that fire was in space. Would it matter if I was 10 feet or 100 feet or 1,000 feet away? There's nothing for the heat to dissipate into. Wouldn't it all be hitting me?
Why would it all be hitting you if it still spreads
because it has
in all
nothing
directions?
to radiate. It has nothing to.
It radiates in all directions, Jeremy. It doesn't radiate only straight at you.
He's talking about the rays that are hitting you.
Temperature. He doesn't
rays
mean
that are hitting you.
Yeah, I know, Jeremy, but all of the rays coming from the fire are not hitting you directly. It's only a small fraction of it. And if you get closer, it will be more.
So let's
Okay, do
talk
you
about the
understand
small
that-
fraction that's hitting you then,
Hold on.
Ed. Quit obfuscating.
Yeah, let's
you
talk
understand
about
that
it
if you're
because
10 feet-
percentage told me it was impossible to survive that. So what's the number of the temperature?
Do you understand that if you're 10 feet from a fire, you'll be hotter than if you're 100 feet away from the fire? Ed?
I know. Yeah.
Okay,
I know.
why is that?
Because it's more spread out. I think it's called the inverse square law.
So it's nothing to do with the heat dissipating into the atmosphere or anything?
He's basically saying, Jeremy, he's saying that these individual rays of light, or like the photons or whatever, over distance will spread out more, so it'll be more diffuse. But he's not accounting for how hot it is.
Yeah,
Right.
but then they'll tell you the seasons has to do with the angle. So is it the angle or is it the distance? What is it, Ed?
Yeah, so percentage, how can I account for it if you're not giving me the number of the temperature? Because you're still not telling me, even after 10 minutes, you don't know. So
Well, what's the
you're still
temperature of the sun?
So percentage, if you still maintain that it's impossible, but you can tell me the temperature, it should
Bro,
be.
what's
at.
the temperature of the sun?
So percentage, let me finish
What
my
is the
sentence.
temperature of the sun?
Let me finish my sentence, percentage.
Finish with the temperature of the sun.
Percentage.
Oh,
Stop.
forget it, man.
Stop. You said it would be impossible to go up there and survive because the temperature is too high. What's the number of the temperature? If you don't
That's
know,
what
you
he
can't
asked
say
you.
it's impossible. Otherwise, you're dishonest.
No,
What's the
he asked you to
temperature of the
begin
sun?
with
That's
what's
the
the temperature of the
answer.
sun, and you won't answer it.
The answer is the temperature of the sun. So what's the temperature of the sun?
No.
It's literally the temperature of the sun, because
No.
again, there's no atmosphere.
We've already been
to
over that.
dissipate the
You're
heat.
only getting a tiny fraction of the radiation of the
It
sun.
doesn't matter.
So it's
Every
not-
single
so
photon
it's
would
not
have that
the
temperature.
of the sun percentage.
Sure, there would be less photons
But it's
over
just-
distance.
right, so it's not
Listen,
the temperature
Sure,
of
there
the
would be
sun.
less
It's only a
photons
tiny
over
fraction
distance,
of
but
it.
every photon would have that temperature.
But it's
right?
only a tiny fraction you're receiving, so
It
it's
doesn't
not
matter.
the
Every
temperature of the
photon
sun.
would have that temperature. So what's
But
the
it's not
temperature?
the temperature of the sun.
It's
Because
the
you're
temperature of the
only
sun. It
receiving a
is.
small fraction of it. So it's not the temperature of the sun.
5,778 Kelvin. That's the
6,000.
surface temperature of the sun.
What's that in Celsius?
Yeah, that's the surface,
question.
so that's not what we're talking about.
It is though, because every photon has
No,
that
it's not,
temperature.
because when you're up in the atmosphere, you're not at the surface of the sun, so it's
I understand.
Well,
I
you're
understand. But
talking-
every
Right, no,
individual
you don't
photon
understand
has
because
that
you're saying
temperature.
it is.
Every individual photon has that temperature. There's going to be less photons hitting
Really?
you over
Do they?
distance.
Do
Yes.
they really? Yeah.
Yes.
It's
Evidence, please.
5,504 Celsius.
5,504?
That's what it says, yeah, from
Damn.
Kelvin to Celsius.
That's from Kelvin, but the atmosphere, the corona, is millions of Kelvin hotter on the atmosphere of the sun than it is on the surface.
Oh, really?
Yeah, it's called the solar coronal problem. That's why the
Okay.
Parker Solar Probe was sent up, because no one knows why that happens. The inverse square law doesn't work with the sun, put it that way.
So my question would be to Ed: does the sun behave like a laser or like a campfire?
My question to Ed is, what percentage of the photons from the corona end up hitting you on Earth, or like, just outside of Earth's atmosphere?
Yeah, well, you know what percentage? You made the claim, so you tell me, buddy.
I didn't claim that,
Yeah, you made the claim that it's impossible to go up there and survive, so you tell me right now.
I said you would think they would melt.
Okay, yeah, based on
According to
what?
your model, you would
Based
think they
on
would
what
melt.
exactly? Based on what?
Based on that, well, let's take the temperature of the corona now. Million
But if you're
Kelvin,
going up there, are you at the corona? Or...
500,000 Celsius or whatever. I
So,
don't
so
even
are
know
you
what
at the corona when you're up in the atmosphere?
No, but the corona is the heat.
No,
that's
so,
coming from the sun, right?
so then what did you base it on?
Hold up, the corona is the heat from the sun.
Then
right?
what did you
dissipating-
base
that's
it
radiating outwards. Sure, there'd be less photons that travel that distance. They would spread out, but each one of those photons would have millions of Kelvin of temperature, right? Of heat. Each one of those photons. So now, how many photons does
Really?
it
You
take?
just said it was 5,000. Now suddenly it's millions. So which one is it?
No, on the surface, he
No,
said
you're
5,000
contradicting yourself.
Celsius.
So which
No,
one is
you-
it?
You was
Learn
the
the
one, Ed.
unit.
Ed, you said not the surface. We're talking about the atmosphere. You were the one that said that.
Right. So
stop
why is he
talking.
still talking about the surface of the sun?
I didn't.
Actually.
I said the corona.
No,
Learn
because
to
you
listen.
then just brought it back and said, no, you said 6,000 earlier. Yes,
Yeah, because
you
first
said
he
you
said the
wasn't
photons
talking
are
about the
5,000
surface.
degrees, and now he suddenly
Oh, so
says
you
they're
wanna
millions
overtalk.
of degrees. So which one is it?
You need to pay
Well,
attention.
Can we cut
you
this
wanna
retard
you
loose
wanna
and move on
you
to
wanna
something
listen to yourself.
interesting?
You want to listen to yourself because you was the one that was saying don't talk about the surface at 6,000 Kelvin.
No, I'm just pointing
Talk
out he's
about the
And then he
contradicting
brings
himself.
up the surface
No,
temperature.
you introduced that contradiction.
No, I'm pointing out he's
You are the
contradicting
one- you are
himself
the one
because first he said
contradicting
the
yourself.
photons are 5,000 degrees, and then he said the photons are 1,000,000 degrees. So which one is
Leaving
it?
the sun, he would be correct. Leaving the sun, they are 5,000, 6,000 Kelvin. Yep, but then when they get to the solar corona, they heat up for some reason, and NASA doesn't know. That's why they sent the Parker Solar Probe up there.
Yeah, and we could boil it down by asking Ed this. Okay, do I get hotter? Does the sun heat me up more the closer I get to it, or does it not heat me up the closer I get to it? Forget everything else, just me and the sun. Do I get hotter from the sun, however it happens, when I get closer to it or further away, Ed?
What's your starting point?
I just threw out everything. I'm standing on the earth. Okay, I don't care how I'm getting hot. I'm just throwing out everything but me and the sun. Me and the sun. For whatever reason, I get hot. The sun is heating me up. As I get closer to it, should I get hotter? Me, not the air, nothing else, not space, just me. Should I get hotter the closer I get to it?
Yeah, but the problem with this is you say forget everything else, but then you say you stand on the earth. So
You said Earth, Sun,
and then I start getting closer to it. I'm standing on the earth, and the sun is heating me up to a certain temperature. I'm standing in a bell jar. Who gives a shit? Okay, now I get closer to the sun. Am I getting hotter the closer I get to the sun?
are you? Oh my God! So you say
Well,
forget
it's-
everything else. So
listen,
is the Earth a vacuum then, or?
It's a simple question. The simple answer is yes. I don't know why he's obfuscating. It
No,
doesn't
because
seem
he's
like
saying
the point.
forget everything else, but then he's pointing in details that.
Yeah, he's
are
going
not-
back. It doesn't even
Yeah, I
like
think
really
I
address
know
the
why. I
argument. But
think
the
it's
answer
because
is a
he's
simple
stuck.
one. I don't know why
He was
you're
stuck a
so
long time
afraid of
ago.
I'm
answering.
simplifying it to point out he's an obfuscating asshole.
Yeah,
I'm
well,
simplifying
you did a
it.
good job.
No, you're not
John.
simplifying.
I'm
it.
with
You're saying
Brian.
forget everything else, and then I say, okay, well, what's your starting point?
Yo,
well,
Ed,
it's
why are
on
you
the
so
Earth.
why are you
so
so
don't forget
antagonistic?
everything else then.
Ed, why are you so antagonistic on this subject? Is it because your last name's Free?
No, you're not being clear, and you're contradicting
You
yourself.
hate to be melted. Your
I'll
last name's
repeat.
Free.
I will repeat. I'm standing on the ground. Okay, I didn't say nothing about the earth or nothing. I'm standing on the ground up there. Who gives a shit? Okay, and the sun is heating me up a certain amount. Okay, I'm in a bell jar. Who gives a shit? I'm throwing out all that other shit. All I'm asking is a simple question. As I get closer to the sun, is the sun gonna heat me up more or not?
You're saying forget all the other shit, but yet you're throwing in other shit. So I don't know what you want, Brian. Seriously.
Fuck's sakes.
And then I was going to say, okay, so if I'm a thermometer and I move closer to the sun and the sun is beaming on me, I don't care what I'm in. I don't care what I'm around.
Okay.
Is the thermometer going to get hotter? Is shit going to melt the closer it gets to the sun, or is it going to get colder? Not talking about the
You
air
tell
around it.
me.
Can I answer it? Because he obviously won't. It's to do with the influence of both the Earth and the sun. So if you were just taking the sun, if we had a thought experiment, you completely removed everything, it was just the sun, you moving away from the sun, it should be that you moving away, you will get colder due to the inverse square law. So the radiation
Yeah,
will
I'm
get
not going to argue with that, Gleam. And thank you for the information on the temperature to narrow this down. But the point is, we can all agree, dude. Our observations show the further we get away from the ground, the colder we get. Period. They could say that it's actually hotter, it's actually this or that. Who gives a shit? You're going to freeze if you start moving away from the ground. You're going to get colder and colder and colder the higher you get. And you're going to freeze or whatever. You're not going to melt. He can't acknowledge that.
Last name.
Yeah, the thing, or the best way I could explain that, and that's where the Earth's influence comes in, where if you imagine a box, you're in a box, and this is a stupid thought experiment, but you're getting burnt in that box alive, and it's just in the contents of that box. with you alone in that box, you'll burn, obviously. But if you had lots of little bits of tissue torn up all around you, filling the whole box, and you can still breathe, obviously, but you've got nothing but tissue in there, everything will burn hotter. And that's because you've got surrounding material that is also burning you hotter. So the fire will be raging hotter. So it's much the same when you've got less of that matter in there.
If you put a plant closer to
let him finish his point, man.
That was it. That was it.
You know, the sun, you move it closer to a flower, it doesn't melt the flower. Am I okay?
That's why I wanted to use
audio?
lasers. Good point, man. I wanted to use lasers because you could put a piece of ice in a bell jar and evacuate it as much as you can, and you can hit that ice with a laser and melt it. You know what I'm saying? You can heat up steel. You know, the air around it might take time to for the convection. I mean the conduction for the radiation to heat up the air, but there's not enough air to heat up. They say, you know, I'm kind of stuck.
Hold on.
I'm kind of go ahead. Let me rethink that.
I don't think heating it up can take time.
What?
Heating it up can't take time.
Heating what up?
Whatever you guys were heating up, it can't take time.
What?
Our main point is the distance. Our main point is the distance.
Did you inject in your eyeballs or just between your fingers?
How could it take time?
Are you purposely being like weird?
No, I'm just asking because I've heard that time is just a concept. So
for fuck's sake.
Okay, yeah.
Go find right the hand.
You know what time is, man. Time is a concept.
It is a concept. Yes, that is 100% accurate.
Oh, so how can something be taken that's just a concept? So
taking
we use
time
it
is a
colloquially.
concept too. You don't literally take time.
Centimeters a concept. We use that too.
Yeah. Distance, time, all that shit. Distance and
So distance doesn't exist. Distance is just a concept.
Absolutely.
No, it exists.
The units are concepts.
You're a
also
concept.
time also is distance. How are those things different or the same?
You're gonna try. Hey, you're gonna try. He's saying all this because he wants to bend it, y'all. He wants to bend it.
He's not interested in an intelligent
bend what? Time or distance? Which one are we?
Let me make it simple for you. Any unit of measurement is a concept. It's a convention.
How about you bring a real argument,
So
man?
is time a unit of measurement?
Nice red herring.
Yes,
you can
by
bend,
the vibration of
bend a yardstick.
crystal.
You can't bend a centimeter. You can bend a yardstick.
Sure. Yeah, but you can time is you can't bend distance either.
Loudy,
so distance doesn't exist, I guess.
Next time you want to do a red herring, don't make the segue so awkward.
Yeah, but you guys are biting into it hard, so I think it's working for me.
No, we're like amazed.
Stop biting.
at how
If you want
stupid
to
the
complain
argument
about
is.
it being a red herring, then stop biting on it.
Loudy, your homework for today is to segue into a red herring in a less awkward manner. Okay.
Yeah,
where
but
people
even
aren't
if
like,
it's awkward, you guys are following me, so it's working for me. I don't care if it's obvious. If you guys are following, that's all I need.
The very topic. Yeah, well done for distracting the topic.
Yeah.
Cool.
Wow. Good job.
He successfully moved you away from where he was floundering like a retarded child.
There's no desperation, but go ahead, continue with the conversation.
This could be a good time to bring up my pressure gradient inside of a container. If you want, I took a 60-foot length of PVC, a bunch of strips, and attached them together. And the last 12 feet of each end of that PVC, bent them around toward each other, and I had them sitting in a gutter, and I filled the gutters up with water. So the last 12 feet of each end of the PVC that's closed off and contained, I had sitting in water. One of them I dumped ice in, so one of the ends was super, super cold. And I mean, stick your hand in there and it hurt. It's like so cold. Okay, and then the other end I had sitting in water, and I took some red hot rebar and put it in there, and I dumped some extra boiling water, vigorously boiling water in the other end. Okay, and I had a balloon. I had a balloon on each end. That was my caps. It's a balloon that I previously blown up to loosen it up a little bit. Each balloon I loosened up, and on each end. So the balloon that was on the cold end, it was limp. There was no air to speak of inside of that balloon, and the balloon on the side with the hot boiling water, it was sitting inside the hot boiling water, was halfway blown up. And so just to check it, I went ahead and I squeezed the air out of the hot side, and it would as soon as I squeezed the balloon on the hot side, it would shake the balloon on the cold side, so you could see the pressure was transferring to the cold side, and then it instantly would blow back up on the hot side. The air. So what I showed in 60 feet was a pressure gradient inside containment, and just 60 feet. It wasn't big, but it was small and it was noticeable and measurable. And I was thinking, what could the creator do in 60 miles or more if I could make a pressure gradient inside containment 60 feet? So what I want to see is an example of a maintained pressure gradient without a container, okay? And I want to see a demonstration of that.
Okay. No, I guess no one's biting, Brian.
I mean, I understood his little thing. It would be cool to see a visualization of it.
I'm gonna bring up the video. Is it in your video?
Yeah, it's the second to last video on flat Earth test.
Pressure gradient demonstrated. Okay.
Yeah.
Do you guys see it on my screen?
No, I still see sunsets.
Okay, hold on. I gotta change the screen here. 1 second. I'll start it over. So far, he's just talking, so you're not missing much. There we go.
Thank God.
Yeah, so what would happen when I squeezed a little bit of pressure out of the hot side, it would make the balloon on the cold side jump, and it would instantly inflate back up a little bit, and then given a few seconds, like 10, 15 seconds, even longer than that, it would start inflating just a little bit more and more, just a steady little gradient, it would maintain itself. I imagine if I had dry ice or something colder than 32 degrees Fahrenheit, that's as cold as I could get the ice water, 33. And then the boiling water, it was a little bit cold outside, so it was, cooling down.
Sorry to interrupt.
Kind of quick.
Brandon, the stream is terrible.
All right, let me stop it and try it again.
It's like choppy and pixelated.
Yeah, this Discord's not the greatest, but maybe it's my computer.
Yeah, even if you...
That's better.
Cool. Oh, you're cutting out, Brian. All right, so I'm trying to figure out what he's doing here.
So basically, he has this really long PVC pipe, and he put it in an arc, basically, and attached like a balloon to each end. You see there's like a little bit of a 90-degree kind of connection, and then a balloon on that. And he put each end in, polar opposite temperatures, and then saw the one that was hot create like hot air that after he squeezed the balloon would move towards the other end, but then when there was no force would basically be pushed due to the pressure gradient back to its original end. If that makes sense.
Okay. Yeah, I'm not too into this pressure gradient argument, to be honest.
Be an internal pressure though, as opposed to an external.
Yeah, basically he's just heating up the air molecules within the PVC pipe and showing that there is pressure gradient within. But he's kind of creating it, so I don't know if it counts.
Well, that's what I did. I compared the sun, the boiling water, I compared to the sun, the hot side, I compared that to the sun heating up the oceans and whatnot, and the rivers and lakes. And the cold side with ice water, I compared to higher altitudes representing, the cold temperatures at high altitudes, because that's what we see in the gradient. And I was just showing how they follow hand in hand, and we could demonstrate that in containment. That was the point.
Can I ask a question? You just used the word "we." Can you define that? We have a guy here. Sorry, there is a guy in this chat who seemingly doesn't handle that word.
Don't be a dick, bro.
I have a quick question, Brian. The two ends have different heights.
Lori got triggered by our DMs, so he had to get triggered on live stream too.
Oh no, I'm just asking because Grid doesn't handle the word.
No one cares, guys. We're talking about something. Okay, so Brian, I see here that the end with the balloon that's inflated is higher. So it could be that there is no pressure gradient sideways like that. And
no, I think
basically the less dense air, the hotter air is just going to the highest altitude that it can.
Okay, the one in the ice water is about 18 inches off the ground, and the one with the boiling water is about it's about 25, 26. It's a little bit higher.
Yeah, have you tried switching the two?
Man, it was a pain in the ass to try and keep the water hot to do it all at once, to get the fire from the steel rods out of the fire to heat the water up. I could do it again. I still have the setup. Them few inches of altitude, man, I'd chop off my left finger if that was making a difference, man. But there could be other things, it's worth talking about. But the point is as long as that heat was there, it kept blowing back up.
Yeah, I'm with you. And it's probably likely that it is, pressure gradient that's horizontal that you're creating from heating it up and stuff. But just so it's definitive, I would leave the setup the exact same, but make the one that was hot now cold, put the ice in that one, and heat up the other one,
Yeah, I could do that. Actually, I did. I pulled the pipe out of the cold water. For a second, I didn't put this in the video because it was kind of tedious. But I did pull the pipe out of the ice water, and it wasn't acting the same. It was the colder. It was, but it wasn't much of a difference. The more difference was the hot water on the one side. The point is we're always asking for demonstrations, and we're always showing them demonstrations. We show them demonstrations of the refraction. Shout out to who is it that makes the? Yeah. Shout out to Skyfree and Pebbles on the Pond. Shout out to them, and shout out to Good Times for All. Showed a little pressure gradient inside containment. And all these things we demonstrate, I just gave a couple quick examples, but we ask for demonstrations, like show us a demonstration of Coriolis. The way they say we demonstrate a merry-go-round and the way Coriolis works. They say it works on the Earth a certain way. Well, then just show us. Show us something besides a claim. And we ask all these things. I have a list of 20 things that they claim that they can't demonstrate, and I'm going to read it over on one of these episodes one day.
Yeah, that'd be cool. I'd like to hear that list.
Yeah, ditto.
Yeah, debunking their
You should
claims.
just display them in a text. Display them in a text in all your episodes right at the beginning.
Yeah.
Yeah, like they say that they say walk outside and you'll see pressure without a container. I say no. The antecedent to pressure is containment. It's I say walk outside and that'll prove containment. You want to show a PVC pipe without a lid on it? There's still containment up there. So I just proved however small it may be, a gradient inside containment. Now I want them to prove one not in containment.
Cool. All right. Anybody got anything else on this? No?
I actually wanted to apologize to the room. I kind of took Grit's and mine dirty laundry.
You got triggered.
It doesn't belong here, so
yeah,
I
you're just a triggered snowflake, dude. You're little
Shut up,
baby.
Grit. Nobody cares.
Yeah, you're just
shut
a
up, Grit.
triggered. You spiral and you trigger everywhere
Quiet,
you go.
Grit.
You do need to go to bed though, Laurie. In all honesty.
He's just a trigger. All you need to know, he triggers all the time. He'll trigger over everything.
Yeah,
and this
no,
is what he
that's
does.
you actually, Grit.
But he was
I'm not the
apologizing.
one who raised it.
Yeah, you always get triggered.
All
You
right.
do too. You triggered yourself.
Oh, you do it too. Yeah. So trigger more.
All you do
Anyway.
is
Carry
trigger.
on then.
Anyway.
Let's not carry on then.
Yeah.
This is what globalists do. They just trigger
That's
and then
not
they
what
act
globalist
like
means.
they
So
feign like they
why
apologize
don't you
for
guys
it.
take
Why
it?
is it?
Why don't you
Nobody
guys
cares
take it
enough.
off
No,
line?
hey, Brandon, I'll tie it in. Okay, nothing changes.
No, we
under
don't
the-
need it
Already
tied in.
tied off.
We don't
Nothing
need it tied
changes
in.
under the sun. It's the
We
same
don't need
crap
it.
every day, right?
All
This
right.
been
Yeah,
it's the
tie it
same.
out. Tie it out.
The same
Beat you.
thing happens today has been happening for thousands of years. The same people pushing the same bullshit.
Why is he still
It
lying?
doesn't change.
Cool. All right, Crit. I understand where you're coming from, but
Roger.
let's bring it back to the sun or some other subject. I don't know.
Percentage. Did you think of something new with these concentric circles or not?
What was that?
Did you think of something new for the concentric circles?
Yeah, I don't know, man. I of course I think that they move in concentric circles, but like obviously it's not complete circle because it's moving from the Tropic Cancer to Tropic of Capricorn, throughout the year. So it's going to be just like it's
slightly
gonna be
off
like
from day to
Fibonacci
day,
sequence, kind of,
Well, I don't know about that, but slightly off from day to day. Yeah, it'll be a little bit farther south or
But
north.
the one thing and this is something I was asking Curved just like a while ago in the other server. Like what is the overlap? What's the time that a single object will have no shadow for? Because if it's like not gonna have a shadow for an hour and then it begins to have no shadow, and then 100 kilometers away you have another object that in 15 minutes or 20 minutes or something, I don't know what the math would be, but
Kosho told
would
me 4
start
minutes.
having no shadow. If there's overlap, we need to find out the zone.
Kosho told me 4 minutes.
Yeah,
There's a
but what's the
4-minute
distance?
period. There's a 4-minute
That would be
period.
that'd be 8 minutes for each side. For each
There's
side
a-
would be 8 minutes.
There's
margin
a
of error.
4-minute period. There's a 4-minute period according to Kosho where the
Over
sun
what
will go
distance,
from
though?
having a shadow to not having it, just the spot you're at. There's a 4-minute
because
window.
Okay, so let's say
Hold on.
hold up. Well, let's say there's an
Okay.
object, right? Just this one thin stick, and it has
Yeah.
no shadow for 4 minutes, right? What about the stick 5 meters away? What about 10 meters away?
That stick won't start until a couple seconds or half a millisecond or something after the first one.
I know, but my point is, what about 100 meters away?
It should
1,000
be
meters
about
away?
35. It should be about 30. It should be about 34, 34 and a half. If the sun itself is half a degree perspective-wise, then it should be about half a degree. It should be about 34 miles. Should be the
Okay, so it's
for
basically
each
this
side.
1,000 kilometers or miles per second times by 4 minutes, which is what, 4 times 60, 240 seconds.
Yeah. Also each side too. So you got to figure that twice. One.
There's
So basically
definitely
240,000 miles. What? Doesn't make
There's
sense.
definitely a margin of. I think you lagged out or something. I had a phone call. There's definitely you're gonna have a little error in your measurement. Like with most measurements, will be a little margin of error. But I don't know. Kosho said 4 minutes, so if somebody's 30, 40, 50, 60 minutes away from you, you have an 8-minute swing between both of them. So how big of a difference is 8 minutes gonna make?
Yeah, I'm just crunching the math. I said miles, I meant meters. So the speed they say is around 1,000 meters per second, right?
No, they say it's 900 something at the tropics, and then it goes to 1,000 at the equator.
Yeah.
and
Okay, so
gradually
let's just
back
take the
down.
equator just to make it simple. So it's moving at
Alright.
1,000 meters per second. You're saying it's 4 minutes that an object will have no shadow. That's
Yeah,
240 seconds. Multiplied
There's something
by
wrong with that.
1,000 meters, that's 240,000 meters would be the no shadow zone at any given time.
Yeah. That'd be
4,000
24,000, but that's something's messed up with that. Because let's figure this. So what can somebody break it down in a calculator? How many miles a minute that is?
Well, there somebody
It'd be
was telling me
240
yesterday.
kilometers.
I think Chike was,
What's it called?
Chike
240
was
kilometers
telling
would
me
be the
yesterday.
zone. So you just convert that to miles.
Chike was telling me yesterday there's a different way to find your subsolar point other than these shadows. It had something to do with hanging a ball from a string with a thing. I don't know, but maybe this isn't the best way to find the subsolar point. Maybe we need a better, more accurate way.
They can't do it. Subsolar point. I looked it up today. The mathematics for it have to presuppose a heliocentric model.
Oh, really? How did you determine that?
Yeah, I basically just Googled it, and there's actually an astrology thing
Because
about
it's a
this.
90 degree on a ball, moron.
Yeah.
No. Show us the math you did, Chris. Go on.
Why don't you go look at where they show you the 90 degree
Yes,
subsolar point
no,
is?
I didn't ask you, so
They supposition it as a ball and then put a 90 degree angle to it.
Tell us more about
Now,
the
a question for you.
1.22 and the 3,000.
Question for you. Do you live on a blade spheroid or do you live on a sphere?
Actually, I was asking.
Flatter
You're
data.
on a blade spheroid.
Yeah, I
or
was
do you live in a
asking
sphere?
Chris, so
So when
not
I'm
you.
looking at the sub, when I look at the
Wasn't asking you though.
When I look at the subpolar point calculation for 90 degrees showing me a sphere, why is that? Why is it showing me a blade spheroid at the 90 degree subsolar point if you live on a pair?
Yo, Ed.
Right.
Today. You're like,
Look at just
Data. Let me
triggering-
ask you a question.
Just triggering these snowflakes.
Crit too. Any flat earthers, feel free. I haven't heard from on this topic yet. If the sun's circling over a flat plane, you would agree, it's going tropic to equator to tropic. The outside circle, whatever one it is, would have to be going the ground speed of the subsolar point would have to be going faster on the outside, right?
Yeah, who cares
Let's
about
pretend-
ground speed?
So what do you talk? I'm sorry. Give me a second. I'll come back to that question. I have to take care of something.
Well, the ground speed would have to be faster, Crit, right?
Who cares about ground speed? At this point, really, if one is going to invoke the sun as their proof of a globe, they better know the airspeed too. They better know what it is, how far away it is.
No,
everything.
For this argument, you don't need to know what it is, how far it is.
It's a deflection. That's why the argument is to deflect away from the nature of creation and to bring in about something that is completely unknown.
Can we get back to the adult speaking, please?
Trigger it again.
For this argument, it doesn't matter if
You're
it's a
saying
hologram.
shit that don't matter.
Correct. For this argument they've brought forward, it doesn't matter really if it's a hologram or a reflection or magnification or
I looked it up.
How
dude.
far away it is, how close it is. Hold
all
on.
day you're getting trolled, dude. I listened on and on.
That little picture, the maths that you did, correct?
No, you can look up yourself.
Oh, so you didn't do anything.
I'm not here to actually do the work for you.
So
if you can calculate subsolar point,
hold on.
see
So,
it.
Crit, what's your problem with the argument?
Yeah, it has nothing to do with the shape of the Earth at all.
Wouldn't you agree that those circles would have to be getting progressively faster as it got towards the outside, the ground speed?
Yeah, the ground speed is completely irrelevant to what the sun is doing in the sky.
It's the whole argument. I know it doesn't matter what the sun's doing for this argument because it's all about the ground speed.
Yeah, and it's a deflection. It's a way to get. That's why the whole day on Gems, I've been tuning on and off. They've been trying to put you against other flat earthers for entertainment purposes. That's what this is about.
So
this has nothing to do with the nature of creation. It has to do with trying to trick you. Hey, left
He's
wing,
being
talking.
commended for doing something.
Hey,
He's
you can
being
shut the fuck
commended.
up. Yeah, you can shut the fuck up.
Yeah, you shut the fuck up.
Yeah, you shut the
can
fuck
shut
up.
The fuck up.
Okay, guys.
Do you guys want to have a real conversation, or do you guys want to just fucking act like
they want to keep the gag going. This is what they want
you
to do.
want to talk forever. That's
They
what
want to keep the gag
hold on,
going,
Crit.
and then I'm letting Jeremy know what.
All right, let me read a couple of super chats here. Cleary, the subsolar point was curved argument 3 years ago. Yeah, he's one of the people I'm talking about that keeps bringing up that this subsolar point argument, and I just want to see actual observation of it, like some real world empirical data. And when I asked Curved in particular for that, he acted like I was a fucking lunatic for asking. Which I don't understand. But anyway, Tony V, US $5. Why am I the only one in the chat that's a paid member? Join the channel. I'm a Glober. Lighten up. Actually, he says tighten up. I think he meant lighten up. Thanks, Tony. Thank you very much. And thank you, Clary. Appreciate it. Okay, should we go back to those guys? I guess.
Our reality. So this is a fun game.
So
I like this game.
Looking up is going to tell you curvature.
Hold on, Crit and data.
No, looking up when we look up at the sun, right? We're gonna get 90 degrees from the sun underneath the sun.
Are we, or is it?
And
a
we're gonna
position? And we're using
the apparent
perspective.
position.
And
Okay,
we're
the
using our
apparent
perspective, and we're using our perspective to measure the 90 degree, right?
Yeah, I mean, if something's 90 degrees, I don't think the perspective grid focuses in on that point, so it wouldn't matter.
The
Why
90
does
degrees relative to your perspective, my friend.
Yeah, how does perspective come into play with this? If
So you're
something's
not
90 degrees.
so the way you look doesn't apply into the way things appear to be?
Yeah, no, it definitely does. But I mean, how is it
Okay.
being a factor in this though?
So are you having a subsolar point on a sphere or an oblate spheroid in your calculation? Because your model says you live on a pear-shaped Earth, but yet
Doesn't matter. It doesn't matter.
Nothing to do
Let
with
me
it.
finish. All your calculations are showing a sphere at 90 degrees. Right?
Doesn't matter.
No. Hold on. We're gonna hold on, Data. Let me respond, please. We're just gonna measure we're gonna do this over land, known land distances, right? And we're gonna see when one person's got the subsolar point. We're gonna start a stopwatch and check when another person's got the
You
subsolar
can't have a
point.
subsolar point because it's based on a sphere. Don't you understand that?
You're saying you can't get to a point on Earth.
There is no subsolar point without having a sphere first. Do you understand?
No, that's not true. No, that's not true.
Okay, so draw me a subsolar point and then give me the shape of what you're driving the subsolar point to. What is it, a sphere?
We could be directly underneath the sun on a globe or a flat. Why couldn't we do it on a flat plane?
You're not
Why
directly
couldn't we be directly under the sun on a flat plane?
You're not directly under it because it's an apparent position. It only appears to be that situation.
You're scattergunning me with shit, bro. Slow down.
Jeremy,
slow down, Data.
Jeremy, a 6 foot person sees what for circumference?
What?
A 6 foot person on the ground. How big is his circumference or field of view? How big is it?
I don't know, 3 miles, or you want the diameter, or
it's 18 mile circumference. So within that field of view, you can only derive a subsolar point by having a supposition that you live on a sphere. That sphere is calculated. Let me finish. Let me finish. Let me finish. Let me finish, please. Let me finish, please. Every supposition that you take is from a 6 foot observer watching the heavenly bodies rotate above you. We observe We observe the rotating heavenly bodies. We do not observe a rotating Earth. Every calculation from a subsolar position has a supposition it's a sphere Earth. So before you calculate a subsolar position, can you show me the sphere Earth?
Okay, we're not calculating anything. We're not doing anything crazy. It doesn't matter what the land underneath us does. All we're doing is getting to a point. So let me finish. Let me finish, Data. It's fair. Now, it doesn't matter what the land under us is doing. Right? We could be on a flat Earth or a globe Earth. Doesn't matter. All we're going to do is get to a position where the sun is directly above us. That can happen on any kind of shape Earth you want. Dinosaur.
Okay, that's not technically a subsolar point. Do you understand that? You have the apparent zenith, and then
why are you trying to stop him, Data? Why are you trying to stop him? Why are you trying to stop him?
Because he's under
whatever you want to call it.
He's under a false premise because there's supposed to be two significant differences between a zenith position and a subsolar point. Do you not understand that?
Are you afraid
whatever you want to call this? Data. Whatever you want to call this, we're just going to get directly under the sun. I don't care what word you put to that.
Both require a sphere model.
You're telling me I can't get directly under the sun on a flat Earth?
I'm telling you no because of refraction. It's an apparent position. Yes.
Refracted sun, whatever. We're going to be 90 degrees under it. Yeah.
Nope. Never. It'll only appear that way.
Why? Yeah, we're going to get under the speed. Oh my God. This is what you're going to get. This is what you're going to get, Brandon. Shit like this.
Anyway, carry on.
The reality is that we're calculating an apparent position of a sun, and then we're telling we're going to have a 90 degree subpolar point based on a sphere, and you're telling me that you're going to get this. You have a fucking religion, Jeremy, and are just destroying it left, right, and center.
What religion?
Ball mathematics.
Just explain the point from a
how is that
point of view.
Fuck out of here, Data.
What was your question, Gleam?
Just explain it from a flat Earth point of view. I've waited for about 20 minutes and I still haven't even got the point, and I really do want to know what they were saying all day in Gems.
Who are you asking?
I clipped some of the best parts, just so you guys know.
Who are you asking that to, Gleam?
I think Jeremy was it. Jeremy was explaining about what they were saying in there.
Oh, yeah.
And they were talking about, what we're going to do. I fully agree 100% that the sun must move faster on a flat Earth model, and there is a mechanism there. But That's what I want you to get to. Were they saying, you need a mechanism?
No, they weren't saying. Nobody was saying I need a mechanism. No,
That's what I
it
don't
doesn't
get,
matter
sorry.
what the. It doesn't matter what the mechanism is that would make it do that. If it's going at their speeds, we'll have to find out. We might have to look farther into it because we've already got that skips across. The point is, we just need to get the measurements and see what it is. You know what I'm saying, and then we'll go from there.
Okay, so Jeremy, why don't you look at the equation of time? It's there already for you. You can see that the sun speeds up and slows down by a constant measurement of 60 by 60 by 24. What's wrong with you?
You got any real world data measurements from this?
So you don't think the equation of time is real world data?
Did they do? Let's see it. Do they have any video?
So here's the formula. Here's the formula. The apparent motion of the sun.
Talk about the
solar mean
speed of
time.
the subsolar point. That's what we need.
No, you don't. That's
Yeah,
not how they calculate.
that's the whole.
That's not how the calculation of equation time works.
Well, then this has nothing to do with what we're talking about because we're talking about the ground speed of
You're
the sun.
talking
data.
about
You're talking about not
which the
shit
equation
that's
of
not
time.
related.
Which
You're
the
talking about
equation.
shit that's not related. Data.
Yeah. Listen, you're talking about the velocity of the sun. You're trying to calculate between 2 points, right? That's what I brought up as an argument. And since I brought it up as an argument, now we have Kosho bringing up the subsolar point. It's a complete fucking red herring. The point is the equation of time shows the speeding up and slowing down of the sun.
It's a small effect.
Okay, then we'll be happy when we measure that subsolar point data. Awesome.
So do you want some quick calculations that you can do just like basic?
No, I don't want
You sure?
calculations. We already have.
show your
We got
calculations.
plenty of
Data.
calculations.
my
We
book.
need some real world
Now
data.
show them.
We need some real world data, some measurements,
Hey,
and then we'll
kudos
see
to
what's
Jeremy.
going on.
Get some
Kudos
real-world
to Jeremy.
measurements. Get her some real-world measurements. Make sure you put a Fresnel lens in there, though. That helps.
Shut the fuck up.
No, I give you kudos, Jeremy. I support you 100% on what you're doing.
What is he doing? What do you think he's
I don't
doing?
care. I don't care.
Question?
I don't care. I don't care what it shows.
I don't either.
Support Jeremy in his effort.
I do too.
I want to know there's
agree.
no shadow zone, no shadow time from Cancer to Equator to Capricorn.
Yeah, you say you know a lot, but you can't demonstrate any of it. So,
Bitch, I said I want to know.
Let's just ignore what you said, okay?
This guy.
If we
So
have,
I got a question.
So data.
If we have it,
you say the equation of time gives you the answer to this. Can you show us the equation of time and show it how we apply it to the Earth for it to tell us that the sun moves faster in the south? Can you break it down for us because I don't understand.
You're gonna regret
asking.
asking.
So at the top of its peak and at the bottom of its peak, it's claimed to be 16 minutes longer than 24 hours, and 14 minutes faster than 24 hours. Okay, this is the beginning and end of its cycle between December 21st and June 21st, in between those variables. In the early months between January to June, you will see that the sun will get slower, speeds up after. Hold on, let me look at my graph here. So, for instance, if we have a 360-degree circle divided by 24.16, which is 24 hours and 60 minutes past, you'll end up with 14.90 degree. Did I do this correct? Which is 14.90 degree per hour divided by 365.25 days ends up with 24.51. I think I did this a while back. I have to go back and double check it. So if you take a 360 degree circle and divide it by 23.46, you end up with 15.34 degrees per hour. Okay. So the equation of time is highlighting the change in degree per hour based on the fact that it's 14 minutes slower and 16 minutes longer throughout its cycle. So as it goes from, let's say, A to B, it speeds up and then it slows down. But in this case, it slows down in the summer and then speeds up in the winter, according to the equation of time. And that's it. That's just a simple way you can see that the sun speeds up and slows down.
And why does it do that on the flat Earth there, Data?
Yo, do you have a write-up for that, Data?
It's in my book. It's not new shit. Just go look it up. It's not new. I just broke it down and looked at the equation of time.
Flat Earth. Yeah,
Look at the equation of time. It's called the apparent solar time minus solar mean time. If they're telling us that we have a constant 15-degree cycle, well, this is easily proven wrong under the understanding that it's 14 minutes behind 24-hour and 60 minutes ahead of the 24-hour. So it says here, what did I write? It says the lowest period of the cycle in February and 16 plus ahead in the highest period in November. This is where the motion of the sun is very noticeably different to clock time. The average movement of the diurnal motion is said to be 15 degrees per hour on average while that will be the average, the sun speeds up and slows down. So it's a quantification of all those it's a common denominator.
You really are just getting a sidereal day mixed up and then calling it the sun.
He's not confusing a sidereal day. What are you talking
Not at all.
about?
I'm apparent solar motion of the sun is what's being calculated here, not Earth rotation. That's what your first mistake is.
And he said diurnal. Diurnal is a 24-hour day. It's a solar day. So I don't know what you're talking about, bro.
There you go.
Oh, he's taking a proof of the globe and saying
So it's in the
flat
book.
Earth.
It's written there, and then what I do
I
is
know,
at the
right?
end,
Of course, you
at
can't
the end-
explain it on the flat
at the
Earth.
end of this description, I add in your comments and I add in your obfuscations and your lies. You can read the explanation. You have the maths provided, and then when I later on, I ask you questions, and then you give me answers, and I write them down next to the responses here. So at the end of the day, it's all a history book I've got here, guys. So thank you very much for participating.
Yo, you should write up your syllogism so we can appreciate it and propagate it.
It's gonna be a syllogism.
Yeah, it's gonna be very silly, isn't it? Because at the end of the day, we're all fighting against flat Earth, right?
Data. You
No.
know the data.
We're trying to find out the
bullshit.
Yo, he was being sarcastic. It was a joke. I don't know why you're taking it so hard.
Well, we know the truth.
So
Dad is
is it-
trying to
is it-
obfuscate it. That's all.
So let me just.
So I
make
got
sure
a
understand.
question. Oh, go ahead.
As a show, is it me or is he just mixing up and trying to conflate sidereal days and solar
Okay,
days?
so listen, RC,
Actually, it's hard to tell about data because he's got a little, just like every good liar, he's got a little bit of fact in there, and then he just puts a whole bunch of bullshit in there with it.
RC, let me ask you a question. When you're going to calculate the movement of the sun, are you going to calculate the rotation of the Earth, or are you going to observe the sun moving? What are you going to do?
Bad boy, what you gonna do?
Silence, motherfucker, silence.
You see
Come on, Data.
the
What
movement of the
I'm
sun is
actually
caused
trying
by
to
the
understand
rotation of the Earth.
Just glaze over that fact, right? Just glaze
no,
over
Data.
it.
No, they see the fact is you think they're different things and they're not. Sun
yeah,
moves
Data,
through the
I'm
rotation
actually
of the Earth.
trying
I
to-
think they're different things.
Yeah.
You're projecting there, bud.
Hold up. I'm actually trying to understand your question. Say it one more time.
When you're
Say it really
calculating-
slowly.
When you're
Really
calculating,
slowly, like I'm an idiot.
when you calculate the movement of the sun, are you observing Earth rotation or the sun movement?
Earth rotation.
Yeah.
Wrong.
Thank you for
You're
answering.
not observing
Write that down
Earth
in the book,
rotation.
buddy.
100% right.
We
100% right.
observe the sun movement.
Nobody cares about your dumbass book, Dave.
Well, that's because you are too stupid to figure out
That's
why
a
the
litmus
sun moves.
test for intellectual dishonesty right there.
RC, check this out. So if Kepler was observing the path of the sun, did he put the Earth on the ecliptic, or did he put the sun on the ecliptic when he was measuring it?
When did Kepler live?
Yeah, did he put the Earth on it, or did he put the sun on it?
We're getting a bed.
Did he put the Earth on it, or did he put the sun on it?
Okay, let me connect again. Sorry about that. I don't know what the heck happened there.
You're talking about obfuscation. Look what you're doing.
That's 500 years ago, isn't it?
So I'm
Was
gonna ask,
Kepler a globe
pretty
earther or
sure-
a flat
no,
earther?
Hold up.
Joe, I'm gonna ask you.
I actually think he used it. I actually think it was in reference to a number of things. It wasn't just the Earth and the sun.
No, why don't you
If
go
I
look at his?
remember
Why don't you go look at his work? He put the
Actually, I
sun on
think-
the
actually, I
ecliptic, and then
think
he reverse engineered it. Go look at it.
Actually, I think it was Sun, Earth, Mars, and Jupiter, if I remember correctly. But I'm not sure.
He took the cycles of he based all of the planetary cycles from watching Mars, and then deduced it from that. But
I think it was
primarily,
also Jupiter. I think it was also Jupiter, if I remember correctly.
primarily,
his
he
model.
observed- primarily
His model
he
didn't
observed-
have. Oh, sorry. Go ahead, David.
Primarily, he observed the sun moving along the elliptical path. Okay.
We all observe the sun moving.
Exactly.
Go ahead, Crit. You were going to say something.
He already had the. Sorry.
Oh, go ahead,
Brian.
Brian.
No, you go ahead. You go ahead.
I would say this is another thing too that the globalists like to deny. They like to say
That's
the
not what
model
globalist means.
was settled. Yeah, get triggered by it. Okay, so
That's not what it means, though.
Yeah, you don't know what it
he
means.
was talking. You can go after the other Brian.
Yeah, that's where it's coming from.
Yeah, he's triggered.
Yo, if you're not gonna let Crit speak a word, bro, I'm just gonna mute you because you're being
He's
ridiculous.
triggered.
Knock
He
it off.
spirals and he triggers. I
Just
got
knock
him
it
when
off.
when he was pretending.
Don't
to
give him
be
any
me.
attention. Just continue with
Okay.
what you were saying.
The globalists like to pretend like the model is settled science, no debate. When if they'll even reject Kepler's models to this day. So I'm only one model away from them. They've rejected 3,000 or 2,999. I've only rejected one more.
Yeah, like how many times have they changed the distance of the sun?
Yeah, countless.
As information gets as information gets more and more better, yeah.
Yeah,
you
so
guys
as
know.
information gets more and more better, we'll see it's a flat Earth.
Yeah.
Yeah,
Just-
we can just change it. Once we're proven wrong, then we'll just add something else to it. We'll just add dark energy or dark matter, or we'll just change the distance to the sun, or we'll just change the size of Venus, and then we'll say that's the best that we know right now. And then when we change it, we'll say, well, that's science.
No
reason
what
why
is red
the
herring
flat
going
Earth-
to throw into this argument, Brandon?
It's not a red herring.
Chill.
Yes, they are.
As you move
Black
on, chill.
Dark matter and dark energy or black matter are definitely red herrings when we come to talking about the
astronomical horizon, geometric horizon. Don't forget those. They're pretty important.
geometric horizon. You see it every time you see the apparent horizon. It's a necessary antecedent.
Sure you do, buddy.
That's right. Yeah.
It's a necessary antecedent, man. You have to have it.
That's right.
No, it's
The
not.
very reflection, the very reflection
Necessary antecedent.
from viewing the
Only in your
geometric
model.
horizon
No,
is not
no, in
actually
every
doing
model.
it.
When
Yeah.
you see it in
That's
real life, you
fantastic.
definitely. That's why the sun
Oh,
goes down the way
absolutely.
it does.
All the time. You see it moving all the time. The geometric horizon moves about the place.
Okay, this is really
No,
important.
the geometric horizon stays in the
it
same
moves
place, but
about
it's
the place.
necessary
It
antecedent.
moves about the place with the weather. Geometric
Listen,
horizon.
you guys, listen. This is important and worth repeating. Okay, there's been thousands of heliocentric globe Earth models. They've all been rejected over time.
Incorrect.
The current one is going to be rejected too.
No,
It
it's
is
only
not
been
settled
improved.
science.
Yeah, you don't know.
It
You don't
is
know how
not-
science
The only
works.
thing rejected
Yeah,
is
it is
flat
not
Earth.
settled
What's your background in
science.
science,
It is
Chris?
not debate. I'm
What's your
only
background in
one.
science?
I'm only one model away
Can
from
I-
you.
No,
in
that's
real
not how
time.
it works.
It will
Can I
go
actually,
back to a
What
flat Earth.
has a background got to do with understanding?
We'll never go back to a flat
NASA?
Earth.
Yeah,
Moron.
it will.
NASA
No, it
Sooner
won't.
or later,
Never
the whole
ever.
house.
No.
Can
Yeah,
I can I
no.
ask you
The whole
can I
house of
ask you a
cards will fall.
clarifying
No way.
question,
It's not House of
Crit?
Cards. Crit, what's your background, please, in science? What have you studied science, please?
What's your background?
What does that have to do
in
with
science?
anything?
NASA shit.
You know my background in science. Go ask
No,
anybody
I don't
here.
know
they'll
who
tell
you
you.
are. I
Who
don't know anything about
cares?
it.
Address the content.
Yeah,
It has to do with
you don't have to
Dunning-Kruger.
make it
You guys
about
are all
me.
at the top of Mount Stupid on
Come on, who are
Dunning-Kruger.
you?
So
why don't
explain
you just
how.
prove your background in science?
Because you think you know, you don't know a lot, and you think you know everything.
Explain
So
how
we're-
the argument is wrong.
challenging.
What's that?
Yeah.
We're
He's
challenging
never
the
going to
known
support that. He's never going to
science.
come up with that.
Hey guys, can we just calm down, slow down? Can we actually have a conversation and talk about a subject? Let's just have a
Models.
conversation.
The flat Earth model should have never been diverted from. It was all based on.
Oh, so you didn't reject the
You're
flat Earth
triggered.
model.
You're
So
already
we
triggered.
actually have
You're already- look at this that quick. Look how quick it takes to
so
trigger
that
this.
means that we have
You immediately
rejected
start
the
talking
exact
over
same
it.
amount
You
of
get like
models.
4 words out.
I
and they
rejected the
just
flat Earth
freak
model,
out.
and you didn't reject that.
Look at they freak
So
out.
I'm actually one model
They
ahead of
spaz.
you
You're
in terms of
spazzing.
what models
You're
I have
completely
rejected.
spazzed
I
out.
rejected the flat Earth model,
I
and
got
you're
4
still
words.
hanging on to it.
4 words out, and they completely spaz.
Go.
4 words. I got 4 words out, and they completely melted down and spazzed out.
There we go.
If they understood science, they would understand the models. They would understand where we came from, where we are, and where we're going. But they don't. They've rejected all science. They've rejected all logic, and they've rejected all reason. They want it to be. They want to burn books. They want to return back to like the good old days of witch hunting and people who think differently than they do. That there's something wrong with them.
Yeah,
That's what they're
we
thinking.
all know that.
But no
Chris. We all
offense,
get
this
that.
this proselytizing isn't really helpful.
What models don't we understand?
Best thing I've heard Crit say though.
Like no
there's
one's
another
swayed
one.
by these
Yeah,
emotional
I'm just not-
arguments.
I'm
We
just
need
not in the
actual
mood. Okay.
facts. Sorry, I didn't mean to overtalk.
I want to have a
Go
real
ahead.
conversation. Do you want to have a real conversation?
Can-
about
yeah,
this,
can
or
I
you
ask
just
I
you-
do.
want
I want to have a
something?
real conversation. I'm still curious how many like photons or whatever of light are at the corona of the sun, and do the inverse square law. How many come to the Earth? You know, how many would hit the same kind of sized object at the Earth? How many
You
photons
tell us.
spread
You
out?
said
And
it would be impossible, and you would melt. So you should know then.
Why would that?
Yeah.
How could you count
Yeah.
that many?
So tell us if you know.
Well, you said the inverse square law. Most of them will be gone, right? So
You said it
how
would
much is
be
most?
impossible, and you would melt. So you have to know
You
the
would
answer.
think you would melt,
Data.
yeah. If there's no dissipation of heat, you would think you would melt.
Same anyway. It doesn't matter. Yeah. So what's the answer then? You made
Here's
the
a-
claim that it's impossible. So
All right,
what's
here's
the
a question.
answer?
Simple question. Don't
No, I don't care about
get
your
triggered.
question. You have to tell me the answer.
Simple question. Simple question.
No,
Let's say
no, your questions
you're
are
in a
irrelevant.
vacuum.
You've made a claim.
Okay, forget it. You're not even worth it.
You made a claim that it's impossible. So what is the answer then?
I'm explaining it to you. If you have the patience
No,
to listen.
you want to ask a question. You're not
Listen, you
explaining
can't.
anything.
You can't listen and understand if your mouth is still flapping.
Then talk. Don't ask.
So let's say you have a one photon. Okay, one steady, not one photon, but one like ray of light with steady streams of photons hitting this person in a complete vacuum, right? They're not going to be there's nothing around them that they're going to radiate to, right? So they're just going to be taking in all this heat, and
you can radiate into a vacuum. You can radiate into a vacuum. You don't need to have anything near you. In fact, if you don't, then you will radiate more quickly.
So no, but this space, this astronaut is in his spacesuit, right? So the stuff
Radiating
is
heat,
hitting
yes.
his suit, radiating to him,
heat.
and if
Yeah,
he
he's
radiates
radiating
it
heat.
back, it'll just be within the suit, right? Not a lot would go
the
out.
suit, no, the suit radiates. That's
So
why
the suit radiates and also shields from heat. How does that work?
Well, it reflects a certain amount of light, but your radiation, the amount of light you radiate, or infrared light you radiate, is entirely dependent on your the constant for the surface, your temperature to the power 4, and the area. So that's a very simple equation to determine how much heat you're radiating. So the wattage is equal to the Stefan's constant times the area times the something represents whether you're a black body or not times the temperature of the 4. That formula holds for the amount you're going to radiate. Doesn't matter. That is just so everything does that, no matter what the.
Okay, can we use that form? Can we use that formula to find out how much of the heat from the corona of the sun will travel to the size of, if the area is the 93 million miles?
Well, we know the
how
energy
much will travel to the Earth.
We know the number of joules per unit area that the sun delivers to the Earth. So if you have an area that's facing the sun, we can tell you exactly how much energy we're getting from the sun from that.
So that's already.
I think it's about 1 kilowatt.
It's inherent.
I think it's 1 kilowatt
93
per
million
square
mile
meter.
figure, right? Is
Yes,
inherent.
so it's based on the distance of the sun, but we can actually measure it as well to confirm this. So we can put out a device above the atmosphere because it absorbs about, I think, 30% or something of the energy of the sun, the atmosphere.
Okay.
So just above the surface of this atmosphere, we can measure the power that the sun delivers to us. And I think it's about 1 kilowatt per square meter.
But how do we know that 1 kilowatt is like whatever fraction they say of the sun that's 93 million miles away?
Well, the area. You can measure that, so we know that's the amount that's getting us because we can measure that with a device up in our atmosphere. So, and then we can say, right, given the sun is 93 million miles away, using the inverse square law, we can then say that is the energy being delivered by the sun.
Oh, so they don't actually know the heat of the sun; they just calculate it based off of their assumption.
We've sent probes to be much closer to the sun, so we know we can measure it from much closer.
Hold on. So the only measurement we have is the temperature from just outside of our atmosphere.
No, I've just told you we've sent probes to the sun, very close to the sun. So that's not the only information we have.
And was it proportional?
I think the current one there is something like within 10 million miles. I think.
What kind of signal? What kind of
so
signal
does
was
this
sending to
hold
our
on?
black
Does
body?
the inverse square law hold true?
Data let percentage continue this conversation.
Yeah. So does the inverse square law hold true for these 83 million miles that were traveled by this probe?
Yeah, of course it does.
Really?
Yeah, of course it does. If
you have like something I can look at that compares the math?
Well, I mean, we can test. You can have light sources on the Earth in the vacuum chamber and see that the power is reduced by that amount. I mean, it's a basic bit of science that you can just consider the surface of the sphere that you've got, and you say all the energy that comes out has got to be contained within that sphere. And then if you've got something like, if the surface of the sphere is twice as big, and you go one of the square root or whatever it is, then you end up with a sphere with the same half the surface, and the same amount of energy can't go anywhere, so it has to pass through both those surfaces. And you can say that it'll be, if the surface is twice as big, then it's going to have half the density. Half
No,
the power.
I get it. But this probe that was, within 10 million miles of the Earth.
There was one launched in 2008.
Let me ask you though, how did it not melt?
Because the energy arrive is not sufficiently great to make it melt, and obviously you can have things that have a reasonably high melting point. I mean, things like the James, what's the one that we've got? Well, anyway, you've got some solar probes, and they've got some heat shields on them, and so you make sure those bits that do face the sun can cope with the additional temperature, and obviously the thing is still radiating like crazy in accord with the Stefan's law that I described earlier.
Okay, do you have any temperatures like from this probe and from just outside of the Earth's atmosphere?
Well, not on the top. I can't, not at the top, off the top of my head, but we know that something like the ISS, for instance, we know the amount of energy that's incident on that, and we know that they have to cool that, and obviously on the shadow side, it's there's a difference of 100 degrees C between one side and the other, so they have to have a system of getting heat from one side of the ISS to the other side to keep the whole thing even.
Yeah, so 100%, and I understand what you're saying. I understand the claim now, and I appreciate you for actually speaking about it seriously, unlike the other guy. But the next thing is to assess the claim. So we need to examine data, like the actual temperatures that these alleged probes had, and see if it actually adheres to the inverse square law and that the wattage over area or whatever the formula that you mentioned. What was that the formula again?
Well, there's the power. You want the power per unit area. So at the distance of the Earth it's about 1.1 kilowatts, I think, per square meter. So obviously, if you then halve the distance, so you go twice across, then it's 4 times as great at 1/2 the distance. So I think so something like halfway between Venus and Mercury is about halfway to the Sun. So at that point, the energy density would be 4 times. So it'd be 4 kilowatts per square meter. And if you then halved it again, it would then go up by another factor of 4. So by the time you get to Mercury, it's probably about 16 times the radiation energy. I think Mercury's about a quarter. It's a bit less. I think Mercury's slightly more than a quarter. So something like Mercury would have about 16 times more energy from the sun per unit area arriving.
Yeah, it would just be exponential.
No, it's not exponential. It's a power. There's a square relation. That's different from exponential.
Square is an exponent, bro.
It's an exponent, but exponential means that the power is in the exponent. There's a big difference between a polynomial, which is you have a fixed number in the exponent, and then having a power and the factor. So something like e to the x or something like 2 to the x. That's an exponential relationship, but x squared is a polynomial square relationship, but and the inverse square law is a polynomial square relationship. So that means if you increase the distance by
it doesn't
2,
really matter if the correct term to use is like exponential or
every time
whatever.
you do it change by a factor of 2, the power changes by a factor of 4. If you double the distance, it's 1/4 the power. If you halve the distance, it's 4 times the power.
All right. Do we have any data for the actual temperatures or the power,
the temperature of Mercury,
energy per area, like squared or inch squared or whatever it was for this probe?
Well, I don't have it off the top of my head, but I mean, just following a simple square law. If it's 1 kilowatt per square meter on the Earth, and you go half the distance, which is halfway between Mercury and Venus, it will be 4 times. And if you halve it again, which I think will be inside the orbit of Mercury, it will be 16 times. So in other words, if you want to take the sun, you could basically ask, can you cope with 16 times more energy from the sun at a probe that be inside the orbit of Mercury? It's basically your question, I think. Can it cope with 16 times more? Well, yes. I mean, if you have a decent heat shield, the temperature on the ISS is only, 100 degrees C. I mean, that copes with receiving the energy. So, but 16 times, okay, definitely would need a heat shield. The ISS would indeed have problems if it was inside the orbit of Mercury.
Okay, but how does that work if they say the temperature of the corona is millions of kelvins?
Well, because the corona doesn't get to you. It's the radiation. I mean, the corona is just a small part of the power of the sun. It wouldn't matter if the corona was there or not in comparison to the overall power delivered by the sun. The fact there's a little flame that comes out that's really hot doesn't change the overall power. That much majority of that is simply caused by the rest of the sun.
Overall power over area
5,000 degrees. I mean, it's 5,000 degrees on the surface of the sun, and that's got a big area, and that's, you know, and then they use the inverse square law on that to get you the power, whatever distance away you want.
So you're saying the corona is basically negligible?
In comparison to the power delivered by the sun, the coronas are irrelevant. Yeah.
What if the corona is like the part that's facing whatever object is feeling this heat?
We're still insignificant. You know, I mean, look at the size of the corona. When you look at the sun and you see this corona coming off, they're not even 1% of the size of the sun, so they're irrelevant. You know, they don't change the overall output of the sun by any.
So it would only be relevant if you're basically the object that's being radiated is right in front of that 1%.
Yeah, if it got him, if you mixed up, yes, okay. If the corona actually, you took it to probe and it actually hit the corona, then yes, that would be relevant. But it doesn't. I mean, that they only come out. I think the corona only come out to about 1 million miles max, I think. Whereas we're talking, you know, I mean, the orbit of Mercury is what? God, I don't. We're 93. Venus is about. I think Mercury's something like 20 million or something. I'll go and find out. So yes, it's not relevant. The coronas cannot get as far as Mercury or the probe, the one we just sent off. I think it's just on its way now, and it's going to arrive. I can't remember. I think it's about 10 million. It's going to sit on, and I presume that would not be close enough to be hit by a corona.
Okay. I appreciate your argument, and I would love to see any sort of data.
I might spend the next couple of minutes trying to get you some details. If
I'd appreciate that, man.
Okay.
Cool. If anyone else has any questions, by all means.
Sum up what the argument is from your side. Percentage. What do you get?
Well, I'm just criticizing the values that they give for basically the temperature of the sun and the distance, right? Because you would expect that over this distance, if these, if the photons or whatever molecules or what have you have a specific temperature, or the way Rumpus put it was better, where it's like power over area because of all this radiating light, right? You would expect that it would spread out, but if it's so hot to begin with, then even if it spreads out enough, it seems like they kind of like engineered the distance so that it would behave in such a way that we would feel the temperature that we have. Like they kind of reverse engineered it. First, they measured the temperature that we have, and then did their math, and then like found out that the distance should be X amount, so it could adhere to their model. But I'm willing to be proven wrong, and I'd love to see the evidence for it.
No, you don't.
Certainly makes sense. If they've reverse engineered everything else, then why wouldn't they reverse engineer that? It's all a mathematical model for the most part, right?
Yeah, but if it's consistent and, then I can't really say anything to it aside from the fact that it's reverse engineered, right? But if it's not consistent, then it would be a glaring error in, the globe model, and you'd have to question why these probes and stuff aren't melting if it's actually supposed to be a much hotter temperature by their math.
Yep, fair enough. Okay. He's
I guess really quick, they could always claim that it's dissipating the heat, it's radiating the heat inside the vacuum at the same rate that it's being heated up. So this might be like much ado about nothing.
Yeah. Right. I mean, it's not like we can verify any of this, right?
No, we cannot. Definitely not.
I mean, really, at the end of the day, if you want to believe it, you have to take their word for it. There's nothing you can do to verify any of it. But checking for internal consistency, I completely understand where you're coming from there. If you can find a contradiction, of course, they're pretty good at explaining away contradictions too.
We don't have any contradictions. The power at Mercury maximizes what? Because Mercury's got a highly elliptical orbit. The maximum power, the wattage per square meter on Mercury is 14,000. So that's 14 kilowatts per square meter. On the Earth, it's, as I said, it's 1.4 on the Earth, 1.4 kilowatts. So the Mercury has almost exactly 10 times the energy, the watts per square meter. The power at Mercury per square meter is 10 times almost exactly 10 times. When it's at the maximum. The minimum is only, because it's got a highly elliptical orbit, it goes down to 6 kilowatts. So in fact, it goes down to only back to a factor of 5 up to a factor of 10, depending because of its elliptical orbit. But it goes up to 50. It goes up to 10 times the power on the Earth. 14 kilowatts. 14 kilowatts per square meter.
How is this measured? You keep saying kilowatts. It sounds like you're talking about electricity. How is this measured?
You don't understand what power is, then? Do you not understand the definition of power?
No need to be condescending.
Well, it is. Well, I mean, there you are. You in a quite accusatory tone, saying, "Oh, you're talking about electricity." Well, I mean, you're just demonstrating you don't know what power is.
You're paranoid. I was just asking a question.
Okay, well, power. Anybody knows what power is? That's joules per second. So something like a heater in your, you might have a 1 kilowatt heater, fan heater. That's quite a warm thing. That's 1 kilowatt giving out, and that is just the energy per second. So watts is power. So you measure power in watts, and watts is a joule per second. And so a heater you might have in your house, a kettle, for instance, be 2 kilowatts. In America, you might not be able to get 2 kilowatt kettles in your kitchen, but we can in this country because we've got 240 volts. So a really stonking kettle is 2 or 3 kilowatts, so you get a third of a stonking kettle's worth per square meter from the sun. And I'd say on the Mercury you get 14 kilowatts. So it's just a rating of the power of sunlight.
And how would I measure it?
Well, you can do that with just anything that measures the intensity of sunlight. And we've sent probes to Mercury, so we know the power there. We've actually sent probes to Mercury that have orbited Pioneer 10, I think it was.
That's nice. That's nice. Do you measure it with a thermometer or something else?
No. You don't measure with a thermometer. You measure it with you can measure the intensity of sunlight. There are various devices to do that.
What kind of sensor is it?
Okay, I'll try.
I'm just curious.
A PV device does the similar thing, like a photovoltaic or solar panels.
Oh, so it's like a solar panel.
Yeah, I mean, solar. Yeah, I mean, you could use a photovoltaic effect to detect the energy of the light coming into you. I mean, don't forget the frequency. Each individual photon's energy is only determined by its wavelength. The thing that actually determines how hot you get is the number of photons per second that are arriving at you, and that measures the power. But each individual photon is energy.
Number of photons per second. Huh?
Yeah, so effectively it's photons per second, but each photon, a yellow, a whitish photon is more powerful than, say, a red photon. So it's slightly affected by the color, but you can approximate it to being the number of photons per second is a reasonable approximation.
Are they using a telescope to analyze the data, Rumpus?
No, we've actually sent probes to Mercury to measure the power of the sunlight incident on it.
Are you sure?
Yes,
they don't.
Sure.
They don't use telescopes.
They could do that as well if they want to.
Okay, so they on average.
But obviously on the Earth, you can only measure what's happening on the Earth.
What's more financially feasible, to use a telescope or launching a rocket with a probe on it?
Doesn't make any difference. We've done both.
Are you sure?
Yes, I'm sure.
So they hold on. So where would they get more of the data from? The telescopes here on Earth or through the probes? What do they have more of for resources?
Doesn't make any difference if we've got enough from both.
I know, but what do they use? What would they rather use daily for reliability?
They'd obviously prefer to have a probe that's there. But
they'd prefer to have a probe. So how reliable? How reliable is the data transfer in the probes?
Very reliable.
Photons have mass.
They're very reliable.
Photons don't have mass, but they have momentum.
So what would be more reliable, shooting with a telescope here on Earth or with a probe 10 million miles away?
Well, a probe on Mercury would be ideal, because then that can get this. That's actually got the device on it, and then it can transmit to us the information. That's what it did with Pioneer 10.
How do you measure momentum?
There are ways of measuring momentum. I mean, you can do that. For instance, when a photon hits an electron, you can measure how much the electrons. And this is how Compton determined that light was going to behave as a particle, because it then hits electrons and it knocks them, and then you can measure the momentum of the electron and therefore say, aha, this light particle, this photon had this momentum.
How do you knock something without mass?
Well, yeah, I mean, light's a bit tricky. It's a bit tricky to understand, but light doesn't have any mass, but it does have momentum. It's all to do with relativistic quantum physics. I mean, I could explain it to you, but
That's not true. Einstein said that frozen matter is matter is frozen light. So that means it's mass.
Well,
right?
it's E equals mc
you've misquoted it then. You don't
E
understand what
equals
he said.
MC squared.
I'm sorry. He believes that matter is frozen light.
Who does? Einstein.
That's correct.
No, he doesn't believe that at all. You just made that up.
Yes, he does.
No, he doesn't. He's somewhat dead as well.
So,
So
quoting Rumpus here. Rumpus says that Einstein does not believe frozen matter solid matter is frozen light. Copy that.
Yeah, you copy that.
Yeah.
So
what
anyway,
does that even mean?
So in other words, the detecting of because the inverse square law is so simple and it's so verified, and we know it happens in so many areas of physics, like just light, electricity, Coulomb attraction, gravitation, all those things we know involve the inverse square law. And you can prove it mathematically by using Gaussian surfaces. And as I say, if you have something radiating out from something, it's got nowhere to go. When it gets to something, a sphere twice as big, it's got to go through the same surface. So we know that if the surface is twice as big, say, that the density of the power going through it's got to be half as much. It's a very, very simple piece of maths. So the inverse square law is well understood. So we know that if we're getting a certain power using a telescope of a distant star, we know, assuming we knew the distance of the star, but obviously we know the distance of the sun, we can very accurately say that this is what the power is from that
How do you turn one of those massless photons into joules or energy? And how do you do that?
Well, the energy of a photon is just determined by its frequency. The energy of a photon, which is in joules, is Planck's constant times its frequency. And that's the simple formula for the energy of an individual photon. But as I was saying earlier, the actual power we get from the sun is actually more dependent on the number of photons that we get per second.
Mm-hmm.
But the energy of an individual photon is Planck's constant times its frequency.
All this is encapsulated in some big computer orbiting Mercury, Pioneer 10 or whatever, right? So
that's what we did. Yeah, we had Pioneer 10, and it was there measuring all the relevant features and around Mercury and the power of the sun at that point. And we sent other probes. We're sending one now with the solar orbiter. We're sending a new probe to the sun. We sent another probe to the sun about 10 years ago that made some measurements. I can't remember. It didn't go around Mercury, but it was near. I think it was within the orbit of Mercury. And we're sending a new one that's on its way, not quite arrived, called the solar orbiter, and that's going to arrive within the next few months, I think, or next year or something. And that will be, as I say, I think a figure of 10 million miles from the sun comes up. And I think it's actually going to have a highly elliptical orbit, so it's going to sort of zoom in and get very close and then sort of zip out again. But obviously, it needs a heat shield, obviously.
So, real quick, Rumpus, I'm just,
Go ahead.
crunching numbers here. So you said Mercury at 10 million miles away has
no, I've got new values
14
on that.
kilowatts, right?
Sorry, it's actually 0.46 of the. So the distance to Mercury, I wasn't quite right about the distance to Mercury. The distance to Mercury from the sun was 0.46 of astronomical units. In other words, it's just under half the distance between us and the sun is where Mercury lives, and then Venus is quite a bit closer to us. So I wasn't quite right about the. So it's basically, you can think of it as being halfway to the sun is Mercury.
Were you right about the 14 kilowatts part?
Yes, I was absolutely right about that. Yes. So it's 14 times. Though, as I said, it's highly elliptical, so that means that the maximum power received from the sun is 14 kilowatts, but it goes down to 6 kilowatts. It varies between those two, but the maximum power it receives is 14, and the Earth is 1.3 to 1.4. It varies as well, because of course the Earth is an elliptical orbit, and so sometimes it changes its distance to the sun by 3 million miles in the period of a year. So that's why it has a small variation from 1.3 to 1.4. The orbit of Mercury is much more elliptical, hence the variation is much bigger.
What's the variation for Mercury?
Between the two orbits, it's 0.3. Oh my God! Yes, it's incredible. Sorry, yes, that's why it goes. That's why I was correct actually when I started off the distance. It is not a third, right? So in fact, the nearest it gets to is 0.3.
No, I mean the intensity.
Oh no,
or like the power.
Right, that was 1.4 and 1.4.
You said 1.4 for Earth.
Sorry. 14 kilowatts for Mercury, maximum down to 6 kilowatts per square meter. So it's quite a big variation. But then if you look at the orbit, it goes from 0.3 of the distance, in other words, less than a third of the way to the sun, and up to nearly half, 0.46. So it's highly elliptical. So that's why in fact, I was correct when I gave the...
Maybe I'm doing it wrong, but your earlier numbers worked out in terms of like the inverse square law.
Yeah.
So with Mercury being 10 million miles away at 14.
Well, no, it's not 10 million miles. That's the.
I know, but that's what you said before, right?
Oh yes, sorry about that.
That
Yes,
gives let me finish.
No, I think I said 10 million miles was the value I gave for the orbiter. I didn't say Mercury was at 10 million miles.
Oh. Okay,
well, when I said this new orbiter. Okay, if you want the exact distance of Mercury, okay, let me try and. Well,
no,
okay,
whatever the one that you said was 14 kilowatts at 10 million miles. That one,
right, no,
the math works.
That's 14 kilowatts at. Okay, let me give you the value for it. The nearest it gets is.
I understand. I'm just saying.
46
1 second,
million.
Rumpus. 1 second.
Hold on, let me just give the final value. 46
all right,
million kilometers. 46 million kilometers is the closest it gets. I'm giving it in kilometers now. 46 million kilometers is the closest it gets. And then it goes far away as 70 million kilometers. So I'm talking about kilometers. So, and that's 0.3 of the distance from the sun to the Earth. And the furthest away it gets is nearly half, 0.466 between the sun and the Earth. So hopefully.
Can I interject now? Can I interject?
The math doesn't work with that as well as it did with the other values that you gave, with the 14 kilowatts at 10 million miles, because that's actually in adherence with the Earth's thing, and it gives a total power of the sun at around 130 to 140 million kilowatts per square meter or whatever.
Per square meter. Hold on.
Not even per square meter. It's just that's the temperature of the power of the sun.
Well, if you're going to do the power of the sun, you need to know the size, the radius of the sun to do that. Don't forget, because you can't put it at a point. This is the mistake that Bob Nodal made about the light from the moon. You've got to know the radius of the sun. Are you using that?
No, I'm not giving you the intensity. That's for intensity.
Yeah, but if you're saying that the intensity at the sun, you need to know.
I'm not saying the intensity at the sun. I'm saying the power.
Okay, the power at the sun then. The power. Are you talking about the total power of the totals?
I'm talking about the total power, which you would calculate the intensities of Mercury, Earth, and the probers, or what have you.
Right, but you've got to do that per unit. You've got to hold on. If you do it from
the formula is intensity is power over area.
Yeah, but the way you're going to work out what the sun is doing, you need to know the radius of the sun, don't you? You can't put it at a point because that would be infinite. So you have to know what the power is being radiated, the surface area of the power that's being radiated from. So you need to, therefore, the radius of the sun, and you need the surface area. Therefore, you then need the surface area of the sun. And
so basically, we have to figure out the intensity of a square mile or whatever. Yeah. So basically, intensity equals the power, the total power divided by
the area,
pi r squared, right?
Yeah. So you need to know you need to include the radius of the sun in that calculation.
Rumpus, are you saying that every light ray coming off the sun hits my receptor?
Sorry, can you say that again? You're a bit quiet.
Are you saying that every single light ray coming off the sun hits my receptor, my sensor? Is that
what receptor? What receptor? What are you talking about?
The one we're measuring the power intensity of the sun.
No. You only need to know how far you are away from something, and then you can say this area here. Let's suppose on Mercury, which is.
Why would I need to know the whole surface area power of the sun?
Well, that's what I think Percent was trying to work out, the overall power the sun was being emitted, or at least the intensity at a per unit area on the sun.
Yeah, that's what I was talking about.
The overall is 400 yottawatts.
Yeah, so if you want it, so if Percent is trying to work out, he's trying to work out what the power per unit area on the surface of the sun is. Which means you need to know the radius of the sun to make that calculation. I don't know how you're making that calculation otherwise, Percent.
Face is talking about something else. Face was talking about in terms of like the device or whatever tool they use to measure this power, how they know it's this entire distance. Hold up, let me finish. Let me answer his question. Basically, they take that device and it has a set surface area, and they just extrapolate to say that it's going to be this amount of power over a square meter.
Yes, I don't know what calculation you were doing earlier, because the only way you can do it is by mapping it onto the radius or the surface of the sun to work out.
I was just solving for the power.
But you have to do it for the surface of the sun. You can't. Otherwise, if you do it to zero, it'll be the power per unit area will be infinite. If you decide to just take this, let me draw a diagram.
Rumpus, where he's coming from, is taking 1 meter square from the sun, leaving the sun, hitting 1 meter square on the
Earth. But you're trying to work out what that is, and that's dependent on the radius of the sun.
No, I did it backwards. So I said, you take Earth, 93 million miles. Each
Shall I show you how to do it?
1.4
If people can
kilowatts.
put up
Let me
with this,
finish, Rumpus, real quick. So you have 1.4 kilowatts per square mile. Multiply that by 93 million miles. That should give you the power of the sun, right?
Hold on. So what did you say again? Sorry.
Its intensity equals power over area. So it basically solved for power by taking the intensity, 1.4 kilowatts.
So the way to do it is to take the total power of the sun at the Earth's radius of 93 million miles is 1.3, 1.4 kilowatts per unit area. So then you divide that by 4 pi squared to get the power, the total power. Or you could just do, well, actually the easiest way to do it, as I say, was to take the inverse square law to get the radius of the sun and the radius of the Earth, and then use the square for that to get, and that would give you the power, the power being emitted per square meter from the sun. Shall I? Let's do my diagram. This is gonna, otherwise we're gonna be here for ages. Everybody get bored. So let me just.
Sure. I went the other way around. I just did it from the Earth and from Mercury just to see if they were consistent by solving for P. Since I had I, the intensity, and the square meter A. You know.
Right. Let's do this. Draw it if everybody's prepared to put up with this.
But I'd love if this math, if someone already did the comparison.
Right, so here we go. So here's the sun.
I did one rough calculation, and it turned out the flat Earth being 40 miles at 4,000 was 40 yottawatts, and the globe Earth is 400, based on a 98% path loss.
Right. So can you see this diagram percent?
Give me a second. Yes, I do.
Right. So, damn it. So if we then, let me just draw a circle from, and that, let's make that.
Oh, and shout out to Geo. Good looking out, man.
Right. So and there's the radius of the sun. So this sun has a radius R, and this distance here is the radius of the sun, from there to there, obviously. It's a little bit thicker so you can see it. Perhaps I'll make shrink this down a bit, actually. Right, so there is this is the Earth here. And so, it's a bit small.
So, Rumpus, I just wanted to clarify. So, Einstein doesn't view matter as frozen light?
I don't think so, no. I mean, I find that very odd if you'd make a statement like that.
What is E equals mc squared then?
That's energy is equal to C times C squared times the mass. That's the energy of something.
Okay, so Einstein thinks that matter is frozen light and light is matter on the move. That's literally what he believes.
No, I don't think he's ever said that. It's not I don't think light is considered matter, and it doesn't have mass.
It's the equivalence principle.
It's what
if it doesn't have mass, how's gravity affecting it? Space-time?
Yes, exactly. That's correct. Actually, that's why Einstein's thing was revolutionary, because light travels in straight lines, but through space times whatever shape of space time.
If it doesn't have mass, why? If it doesn't have mass,
but it still travels in straight. Tries to travel in straight lines even without mass, and therefore it will just simply follow the curve of space time, and mass changes that shape of space time, and it goes in a straight line as far as it's concerned through.
You've got something physically. You've just put something physically bending out there now. Something is physically bending.
Effectively, it's what space-time is, yeah.
So, Rumpus, you just...
some tangible... Go ahead.
You just proved yourself to be, like, pretty stupid, right? That's exactly what Einstein believes, that matter is frozen light, and light is matter on the move. That's literally what he believes.
You give me a quote for that.
Hey, Gleam, you just told him to it, right? It's the equivalence principle.
So you don't have a quote for that. You just made that up. I thought so. Right.
Hey, before you start,
the equivalence principle is that energy is equivalent to mass times its
and photons don't have mass. So I mean, I don't know what the hell.
Well, that you expand that out to the PC, don't you? So it is momentum instead of the mass.
PC. So what's PC? Sorry, PC. What?
No, there's two different versions of E equals mc squared. One you use on mass, and one you use on photons.
Right. Here we go. I'll write you the equation here. E. This is the full one. This is the full relativistic equation. I'll write this down.
So, Rumpus, he literally believes matter is frozen light.
No, he doesn't. Well, I find that difficult. I mean,
or matter and energy are interchangeable.
Right.
Yeah, and mass and right. So let me just zoom in onto this formula. This is the one that I think Gleam is referring to. This is the rest mass here. I'll call that MO.
What do you say? They're opposite heads of the same coin or something. I think he phrased it as matter and energy.
This is C
different
squared.
sides of the same coin.
Right. So
Yeah, but only without the speed, right, Jeremy? If you take away the speed, then M equals E.
This is the.
I don't know. I think he used a coin to phrase it. I'm not sure.
He used the coin to phrase.
Right. So the full formula.
Let me read
It
these
does
while,
say
while
here, just,
Rumpus is getting his
You
shit
go ahead.
together real quick. All right.
Yeah, go ahead.
Make sure you do it all audible over the mic, Rumpus, while you're getting your shit together.
Jeremy's right.
Mumble through the whole thing for us.
What the fuck is this, Rumpus? This
Hold
isn't what we were
on,
talking
guys.
about.
Hold on.
Oh, yeah, sorry, but I got Gleam interrupted, so sorry. Yeah, I'm sorry, percent. I'll get back to you in a second.
Give me 2 minutes, guys.
Okay, go ahead.
Thank you. Cleary, Kosho is using Jeremy to gather data for Curved. Thanks, Cleary. Are you an agent for Kosho and Curved, Jeremy?
No, I'm not. I'm not an agent for Kosho and Curve. They presented an argument, and we're now about to look into it and see if we can verify their argument or not.
They're presenting an argument based on what I told them about measuring the velocity of the sun between 2 points based on sunrise. All of a sudden, they come up with subsolar point.
They've been saying that for a long time. They just never
Yeah.
provided
Have they?
any
But they have
actual
assumed
empirical
the
data.
speeds. They've
Well,
assumed the speeds
it's
and
new
like
to
the
me.
temperature. The time where the thing has no shadow and stuff, and we need to confirm that.
Yeah, we need to confirm.
I mean,
that. We
normally
need
the
some
burden of
actual
proof would be on-
empirical data for the claim that they're making.
Normally, the burden of proof would be on them, but they're never going to do it because they already think it's a ball. So it's up to us once again to do something.
Right.
Yeah.
Silent Zero.
No worries.
They're helping. Hold on. They're just to be clear, they are helping, giving me latitudes. I think I only have baller latitudes right now. So.
Silent Zero, $5. You will not find holes in their history. They've been perfecting the model for a long time. Yeah, they've had a long time to get it all together.
That's true. They have been.
Except for there's inconsistencies with time frames of darkness in Antarctica. I've got reports from 4 months to 7 months to 9 months to 6 months.
Oh, really? Show the data.
Well,
so you can read it in my book.
What's the data?
Well, they used to say that the distance to the sun matters not, because you could change the size of the sun with whatever the distance you put it at.
Exactly.
But as we're seeing now, I can't remember who said that. Aristotle, Galileo, or Copernicus. It's one of those three.
Wait,
Distance
Flutter?
to the sun matters.
Yeah, and as they change the size, they also
But
have to
nowadays
change
they would be
the
wrong.
power.
Nowadays they'd be wrong, because obviously the size of the sun would emit different power energy.
No, they'd adjust that.
Percent. Where's your data that there are different times in the southern hemisphere from the same spot?
One more, guys.
What?
Hold on. We can
the book.
hold on. We'll save it a percent. Answer it in just a minute. Let me get through this one more, and then we can be done with it. Thanks, Silent Zero. C4, $5. Percentage is super boring for a Poe, and I bet his farts smell like Vaseline.
Okay. What does Vaseline even smell like?
But you would know.
Anyway, so
C4
so
doesn't mean plastic explosives anymore.
That was
so
important.
percent.
So I had to get that out. Go
So
ahead.
percent. Where's your data that from the same point you have, for example, like the winter solstice being different times?
Thanks, C4.
Did I say that?
You said that there
was
are
data.
different times.
I said
Data
that we need to
Data
confirm.
said it.
Listen, I said we need to confirm the times at which an object has no shadow, for how long it has no shadow, at the different latitudes.
All right, data. Where's your data?
Good call. Good call. Percentage. We definitely need to see how long this no shadow. That's a good call. We definitely need to see that real fast. I want to find that out. Like, we should be able to do that tomorrow. Where's this subsolar point at tomorrow?
Yeah, you take the same object, and if it has no shadow for longer or for less, that's basically telling you how fast the sun is moving at that location.
Okay. Do we have any data on this?
Do you have any data?
Yeah.
All right, then present it.
We've
Oh,
already
well, hold
seen
up.
it. They got timeanddate.com.
I was gonna say just go to timeanddate.com, but Data was the one. Data was the one who made the claim that there are different times that are happening. That
Yeah,
so you got the sunlight.
So Data, hey, Data, present your evidence.
Hold up, so you got me confused for Data, right, RC?
He said the sunlight times in Antarctica. I think he was talking about.
Okay, so that's why I want to say, Data, go ahead, present your evidence.
It's
So
in
you
the
buy
book.
it in my book.
It's in the book.
Well,
Yeah,
where's the book, Data?
I'm trying to complete it. I thought I was going to be done this December,
Oh my
but
gosh!
it's just,
Well, you
it's
can,
just, or last
can
December
give-
passed, but
you can
things
give it.
got-
You can
things
give us.
things get a little bit more complicated, so I have to not because it just gets too complicated. So I'm limited on what I can actually resourcefully do myself. So
Okay,
basically,
Data.
a lot of the data that's derived is from archival information from earlier explorers and showing
Oh
the
my gosh, data.
inconsistency in the data between that. Like a lot of you guys think that USA discovered Antarctica and all this shit when it's actually
Okay,
Russian communism.
Yo,
that
Data, just say
discovered
you
it.
don't have it yet, you know, you're working on it, and that's it.
It's written down in the
Come
book.
on, let's
but,
go poop right here.
So hey, Data.
Jeremy, your mic.
I don't know.
Have it at least
Let's
written.
go poop right
you
here,
have it at
please.
least written
Jeremy, your
down.
mic.
Be in the potty.
Jeremy.
Sorry.
No, that's all right.
I got it.
Can you just
Got
give
a lot
us
of
that section
potty
of the
training
book?
to do today.
So RC, when
No.
you strawman me, you really just confused me for
Doesn't
Data,
exist, RC.
right?
What's that?
When you strawman me, talking about this, different distances or whatever, you really just confused me for Data.
Oh, I couldn't tell you guys were talking at the same time, and I was trying to figure out if it was Data or you who said it. So I'd like to know if Data
So
actually
you did that by
has the
straw.
data.
Oh, that's cool. I'll accept your
It's
apology.
not a straw man.
I accept your apology. It's fine.
Data.
So Data,
don't
where's
give
your data?
any of them anything. Do you understand? Don't give any of them anything.
No,
You keep all off your book. Don't
Yeah,
leave them have
exactly.
anything. Don't answer any of their
It's
questions.
not in the
You
book,
don't
though.
deserve answers.
He doesn't have any evidence.
How
in the
about this? Why don't you just go?
I love
research-
Brian's
why don't you go
logic
research-
accent.
Why don't you go
Just
research?
get ARC.
Yeah, why don't you show your evidence?
Let's
Why
say
don't
you
go
got
research
I got
what's
you.
Show your data.
what's written down? I'll
Just
give you
drop it.
I'll give you some names of some explorers if you want.
Data, I don't want your excuses. I want your data. Your name's Data.
You can buy it in
You
the
said
book.
you had data.
No,
Show me
it's
the
not
data.
in your book.
Show me the data.
Yeah, it's
That's
not
all
in
I
your
want.
book. Don't buy
Have you
it.
got a reference somewhere we could go look at this data? You had to have tamed it from
early
somewhere.
explorers. Yeah.
Data.
Fantastically.
Give me the
You
specific
can find it all in his
explorer.
book. Just buy his book. Don't give them anything. Tell them
No,
not to
don't
give them
buy
nothing.
it. It's
They
not
don't
in
deserve
there.
anything.
No data.
So
data.
RC, if you
So
haven't
Shane-
done any data yourself and you're going off of
No. Hold up. Hey, this is
hold
not.
on. Let me finish. And you're going off of heliocentric, I guess, priests. Take no offense on that, right? Aren't you just confined within the map?
No.
Like everything would add.
No, I already
The
answered
data
your
they
question.
give
No.
you would be correct, right?
No, the answer,
You could
yes,
prove
the
their
data is
data.
correct. The data is correct.
Right.
You can check the data.
Right,
Yes.
but aren't you just confined within that data because
Oh,
you
you mean
didn't,
I'm confined within observation and measurement? Yeah, I'm confined within observation and measurement.
well within the map?
No, there's
is
not
that-
math. It's observation and data.
And that's
Well, your
Apparently
map keeps you
apparently
confined.
apparently that the guy named Data doesn't have, which is ironic.
Well, let's
I'm
say
here
you
to-
even
I'm
got
here
him
to
on
go
that.
through the
Let's just
data
say
and
you got him
compile it.
on that.
But you're
Who
never
cares?
showing
Drop
any data.
it. Changes.
I'm here to
nothing.
go through the data, compile on it. Once I
Data,
compile it,
you're
I
never
ask you
showing
questions.
it.
I ask you questions about it, and then I put
Data,
it next
Yeah,
to the data.
what
to
is
collect.
data. Hold up. Data. If you haven't even compiled it, how are you now drawing conclusions that it's inconsistent? If you haven't even compiled
So,
it,
are you divining my thoughts and what I've done?
I'm asking you, where's the data? And if you haven't compiled it, then how are you drawing conclusions from it? It's not a hard question.
It's. I'm just going to tell you again where you can find the data
All right,
yourself.
where? Give me a citation.
No,
Go
don't tell him nothing,
research
dude.
earlier explorers. Go
Yeah,
research
Which ones?
earlier
Which
explorers.
ones? Which books?
There's
What
at least
It's hard
page?
to
6 of them.
publish a
There's at
book
least
if you tell
there's-
everybody what's in the book.
No, not
Nobody's
really.
We're not
fucking
gonna buy it.
Because
Data.
people are
Data.
lazy, right?
Which explorer? Which book? Which
A lot of
page? Just
people's
give me
gonna
that.
buy it.
Go
Come
look
on,
for
Data.
yourself,
Which one?
brother.
No,
Go look
which
for
one?
yourself.
Which?
Right, so
All
he
right.
doesn't have
Which
it.
explorer? Data. Which
Right.
explorer?
Yo, Data, we could just end this by saying you don't care to substantiate your claim just yet.
No, he doesn't have the
So they
data.
can
That's
reject it
the-
if they
that's the
want,
problem.
and then
Mr. Data
whatever.
doesn't have any data.
Yeah, but I'm actually telling him. I'm telling him that the information is in the early
telling him
explorers.
fake stuff.
No, if you're gonna tell them where it is, you could be specific. If you're gonna substantiate it, do it with substance. If you're not, then it's cool. We could just move forward. They can reject it if they want. Whatever.
It's not about rejecting or accepting. It's about saying a man named Data says he's got data. Hey, Data, can you show me your data? And he's like, nah, man, I don't like to show my data.
We could just call him Data in his pocket.
Or we could
he could just apologize for making the claim when he didn't want to reveal it.
The guy's name is No Data. For the love of all good and holy.
Fantastic.
I'm not even asking for your conclusion or for your eloquence. I'm just saying, show me the data. Show me your Excel spreadsheet.
Show me the money.
Give me a mother-loving reference of where you're even getting your data, and that would be
So
sufficient.
I'll give you one guy. I'm going to give you a guy.
Cool.
Okay?
Awesome. I'm ready.
Don't
I'm so excited.
Don't do it. Don't give him
I am
anything.
so freaking excited.
It's in this. I'll give you some. Can I give him hints? Can I give him hints?
No.
What do you want to hide the evidence, Brian?
Couldn't you just say Zatanic?
What do you want to hide the evidence?
You can give me your mother-loving data.
So
where is it, Data?
He's an admiral.
Data, just say the freaking citation.
This is one book. This is
Data,
you can go
just
research
say
it.
the citation.
I love
Data,
how you hang on.
Your
for every
nervous
word I
laughter.
say. It's
Your nervous
fantastic.
laughter. Your
I
nervous
don't
laughter
know,
doesn't
man. You
help
got
me.
pretty good control of him right now.
He's trying to tell you, shut up.
Maybe you should not say anything.
Well, that's the whole point. I'm just watching him flounder, so it's pretty fun.
I'm floundering, and you won't give me any data, and I'm floundering for the love of all good and holy.
How many firsts were
Right,
there?
so what's the data then?
Okay.
Data? Because you're running again.
Okay, it's nothing new, fellas.
Yeah, so then tell us, what is it?
It's nothing new. You can go research it
Right,
yourself, but
tell us.
it'll require you to use your fingers.
Right, so
and
just tell us then, what is it?
And type in early explorers.
Damn.
That's
right.
great.
Shut the fuck up, Ed. Let him finish.
Flounder.
He's triggered.
So
you're RC, you're cutting out, I think.
Yeah, somebody's
cutting out.
I think it was RC. I could be wrong.
No, it's RC.
Yeah, it was RC.
Okay, well, Data. I kind of think it's a fair ask to ask for the data. I don't know why you guys are pushing back.
It is. But here's the thing: it's if you take your time and you type in early explorers and go through all of their accounts.
Which one? Which one?
If you go through all their accounts, there's lots of
which one
tidbit information.
specifically?
Well, there's lots.
Yeah, so give an example.
Here's the premise. I'll set it up for you. When you are a first-time explorer, if you're a first-time explorer, you're going to see things. You're going to see things, and generally, you're going to generally report what you see and observe. There's not going to be any bias. There's not going to be any bias in your reporting. The thing is that if you have all these earlier explorers kind of having a consistent report on what they're observing, then there's some data there that you can compile. And then as you go, you notice that after 1958, you notice the data changes. Well, what happened in 1958? Anybody know?
Which data?
Do you know what happened in DARPA? DARPA happened.
Well, NASA was first. NASA was up.
Well, no, hold on. NASA was a great organization before DARPA got involved.
It was the first CIA.
Well, when DARPA got involved, that's when it went from honest men to propaganda and basically Nazi propaganda. So if you look prior to NASA, which is called a different name in the early 1900s, it was really good men that ran it. In fact, if you do research some of these early explorers, they have nothing but bad things to say about Captain Cook.
Can you get the name?
And yet we have Captain Cook all over, all established through Canada here in statues, especially on the West Coast. But when you look at the literature, there was a lot of contention about Captain Cook and what he reported. But anyway, you can read it in my book.
No, we're not going to buy a book that has no data in it.
So, Rumpus, where are we?
Right, yeah, I'm just nearly there. Yeah, I got the right answer. Okay, so here we go. Right, so I've just quickly covering what Glean was quizzing about, the energy of a photon and things. This is the equation I think that Glean was referring to, the Dirac
Yep,
relativistic
exactly that. You got it perfect.
Jolly good. So this equation here is the energy squared is equal to the rest mass squared times the speed of light to the power of 4 plus the momentum squared times velocity of light squared. So this is a Dirac modified the Einstein's thing to make it relativistic. The E is equal to mc squared. So in the case of a photon, the rest mass is 0. So this term becomes 0, and therefore the energy of a photon is just equal to its momentum squared times c squared, which then reduces to. Let me just get that stupid bloody subscript off. So if this term is 0, then e squared becomes, if that term is 0, if that becomes 0, then E is equal to that, and that means that that's equal to E is equal to PC. Oh, bloody subscript! Sorry about this. My subscript won't come off. Right, there we go. Which is equal to which is then so that, and therefore the energy of a photon is equal to P times C.
The momentum.
Hold up. How does a
times the speed
photon
of light.
have momentum when momentum is the product of mass and velocity?
Well, that's because you're using the simplistic classical idea of what momentum is. But you're correct to say that the classical momentum is mass times velocity. But the case with relativistic things and quantum mechanics, things get more complicated, as you might imagine. And the momentum of a photon is actually equal to, from this formula here, is actually equal to E over the, so the momentum of a photon, P.
So they change the rules for light just to make it make sense in their model.
Mic check, what's going on,
It
everyone?
is the odd one out.
Quantum mechanics is complicated, and the fact you
Yeah,
don't
light
understand
is magical.
Yeah, well, hold on. So in other words, the momentum of a photon is equal to its energy over c, and the energy, as I told you, of a photon is equal to Planck's constant h times its frequency f divided by c. So the momentum, and that in fact is equal to h. Let's just try that again.
How dare you not put that little dash on the H?
Is that
I'm
is
joking,
equal
I'm
to
joking.
h divided by the wavelength, which is lambda. So let me just get hold of the lambda symbol. So is equal to lambda. Let me just see if I can get that bloody thing. The right symbol for it.
Just write lambda.
Well, it's nearly there. I've got the character. I just need 2 seconds to bloody click the right thing.
Just turn a V upside down quick.
Hold on, I'm nearly there. Bloody come on, lambda, where are you? It's in this bloody. There we go. Got him, bastard thing. Right, here we go. It's coming in.
That dark energy stuff.
Incoming. There we go. H over lambda. So the momentum of a photon is equal to h divided by the wavelength of a photon.
But that H should have a little line in it out of respect.
No, it shouldn't. No, it shouldn't. No, you get
I
confused
thought
with.
I thought the Hamiltonian had a little tick in it
This is the
because of
momentum
him.
of no, that's not h over 2 pi.
Oh, I'm wrong then.
So there you go.
Hold up. Rumpus, what is it?
So there's the momentum of a photon. It's h over lambda. Let me just make absolutely sure I did that from memory and I did that mathematically. Let me just check. I haven't made a cock up. I'll just go and check on the. I think I'm right. Let me just go and check.
Rumpus cheat sheet.
Gleam, why do you say H as H?
Because I'm English.
He's English too. He says it properly.
I know, but I don't say it properly because I talks from the ghetto.
He does.
According from posh.
You from the black country?
Nah, I'm from down south, mate.
So, right. So there we are. And I've just checked this. Although I derived it actually here, I must admit I'd forgotten it actually, and I derived it in front of you. That is the correct answer, and I've just checked that on the internet and on scientific websites. So that is the correct momentum of a photon, and as you can see, it's not related to its mass. It's derived from this equation that I showed you here, and it just. I know in classical physics we call momentum mass times velocity, but quantum mechanics is a complicated thing, and you've got this massless particle that in fact still has momentum. I mean, you can tell this. You can shine light at things, and we've got this sort of sail technology where you can shine light at things, and we have the power of sunlight, and it actually applies a force, and that's through its
Doesn't
momentum.
the photon
Maybe the light.
Photon hit a sensor? For them
Maybe
to
the
detect
photon is riding like a molecule of ether.
No. With the
A particle of ether.
No, there's no such thing as ether. That's been dismissed.
Is that so?
But anyway,
It's a field array. It's a field array.
But I want to get back to the
field array.
point.
It's a
I want to
field
get
array.
back. So having demonstrated what momentum of a photon is there, and the relativistic version of the E is equal to mc squared is, I just want to get back to Percent's question about the power of the sun. So this is how you do it, Percent. So
hold on. Wait a second.
Hold on, James.
Wait,
I was in the middle of answering Percent.
Let James go.
It
Real
has
quick.
to do with what you was just talking about.
I know, but that was a tangential thing off. Anyway,
about
carry
the
on.
photons.
Yeah,
About
okay,
the
Count
photons.
James.
This is
Count
a
James.
honest question out of ignorance.
Okay, go ahead. Go ahead.
The photon, doesn't it hit the sensor for you to detect it?
Of course.
And when it does, like, obviously there's a light on the sensor. Are they hitting these photons?
No. Hold on. There's not. Well, there's not a light. What the photon hits the sensor and it displaces an electron.
And it displaces an electron, right?
Correct.
So my question is, and there probably has been, have they done an experiment where, you could take the photon out of the light, right?
The photon out of light.
In other words, what I'm asking is a photon?
Photon is light.
Is a photon within light?
Hold on, it is light. That is what light is. That's like saying taking
them both as a whole.
No, hold on. Photon is light, so you can't separate. You can't take the light out of photon. There is.
So
light.
when the photon hits the sensor of the light is on the sensor.
Of the light.
Do they hit consistently
hold on. Stop.
in every place?
Stop. The photon hits an atom inside the photoelectric sensor, and that displaces an electron in the atom that it's hit, and then you detect the current of that electron.
So how do you know that the photon, that's hitting the sensor, is the light? Like, is it hitting consistently all around? You see what I'm trying to say? Like, if you shine a flashlight,
see what you're trying to say. I'll go through it again. So a photon is
okay. Hold on, Rumpus, because this is where you're not understanding what I'm saying. If you shine a flashlight at the sensor, and you see in the light on the sensor.
Who's seeing? Who's seeing? So you keep on talking about someone seeing something. Who's seeing?
Do you get a photon? Do you get a photon in the dark?
Hold on, let me just try and clear up your language. You switch on your torch, and that fires a beam of photons at your sensor. The sensor, there's a particle inside an atom of something inside the sensor. The photon hits the electron.
Why do you have a torch instead of just a light?
A torch is like a flashlight in British speak.
Right,
okay.
So you got a torch, you switch it on, it fires a beam of photons, which is light, at your sensor. The photons hit an atom in the sensor, they displace an electron, that generates a current, and you measure the current.
And are those photons? Hold on. Are those photons consistently hitting the light on the sensor?
The light? What's light on the sensor? You keep on talking about the light on the sensor. What light on the sensor?
Yes,
the light that you just shined on it.
Okay,
when you shine a light on the,
you keep on talking you keep on saying that hits the light on the sensor. But the light is the photon. Stop talking about the light on the sensor.
You're not understanding my question.
You keep on saying light on the sensor. That doesn't make any sense to me.
Because you're not listening, Rumpus. Just listen for a second.
The phrase doesn't make any sense.
It doesn't matter. He's basically
let me
saying
finish and I'll be quiet, okay?
Right.
If you're in the night and the dark,
in the night,
you shine
So you're saying light or night?
You didn't let me finish.
At night, in the dark, you have a flashlight.
I'm trying to get you in a perspective of my
Don't light night him.
So I'm going a little outside the box just to get you in my perspective of thinking. Hold on. If it's in the dark, if it's nighttime, you shine a light on the. Damn, dude! You shine a light on the ground, a flashlight.
On the ground.
That light is a circle, right? My question is, on the sensor, is the photons hitting that circle consistently, or are there patches of no photons and they're actually within
Sorry, you're talking about the ground
light?
and the sensor. I got confused. I thought you were shining the light at a sensor, and now you're shining at the ground. What are you doing?
His question is basically: is the light that's hitting the center isotropic? The sensor, the light that's hitting the sensor, is it isotropic? Is it ubiquitous? Is it homogeneous?
Yeah, is it homogeneous? Okay, yes, it's going in all directions, and it's homogeneous and isotropic. Yes.
So your photon sensors
go out in all directions, and they're all the same
would be
density.
a perfect circle of the light that's hitting it, like the circle of the light that's hitting it. All those photons on the sensor.
Well, if you shine a light down, if you're shining a torch downwards, it's got a spread of light. It's there's no sharp point of ending. It sort of gets less and less dense the further it gets away from the point you're shining down. So, in other words, if you had a sensor directly underneath the torch, then that would be the maximum thing. And as you moved it further away from this axis of the torch, then it would get dimmer and dimmer.
You understand, James?
I guess.
Basically, he's saying as you move the light away, the light will attenuate and it'll become blurrier.
The sensor away.
Yeah, it'll become blurry at the edges, just like a shadow on a wall. If you get farther away, the shadow gets less crisp.
I mean, if it was a perfect vacuum, I mean, if you were holding a light source and it was in a vacuum, then then it would be radiating in all directions and it would only be dependent on the distance. But you're talking about a torch with a focusing lens on it or something, so you get all sorts of other effects. You're complicating it. If you just want to consider a light source sitting there in a vacuum, in some dark bit of space, then the intensity is uniform across the sphere surface outside of it.
All right, Rumpus, my question is
it exciting molecules?
Hold up, so you said that this photon is hitting the atom.
Yeah.
What's the size of the photon hitting the atom, and what's the size of the atom in comparison?
Right, well, photons have a wavelength something like about 300 times the size of your typical atom. So if you want to think of it like that, it's difficult to think. I mean, it has a wavelength. So what the actual size of a photon, you can think of it as one wavelength.
Hold up, I thought light could only be a photon or a wave at any given time, not both.
Particle
Correct.
wave. Which one?
Correct, but it has a
So
wavelength.
how could it be hitting as a photon if it's the size of the wavelength?
Well, because the quantum mechanics says...
Is a photon a particle or a wave? Which one? Frequency or particle?
Well, that's a very good question.
Okay.
That's something that is difficult to answer. It behaves like a particle sometimes. So, for instance, in this particular example we're discussing here about colliding with an atom, it behaves like a very small particle, but it actually has a wavelength. Usually the sort of visible light is something like 300 times the size of an atom. But it actually acts like a point. It actually acts like a point particle when it actually interacts with an electron. And
so
this is what
physically collides into an atom, dislodging, moving an electron, as if it was a particle with mass.
So it hits an electron like a point particle,
with
but
mass.
It does have a wavelength. And so it hits an electron that's in in the surface valence layers of an atom.
Would
and
that be an electron?
Hold on, nearly there. And it knocks it up. It knocks it up a level. Hold on, it knocks it up a level, or knocks it off the atom, and then that forms a current. Finished.
Okay, but even if it was going to hit this electron, and the wavelength, the total size is 4 times the size of the electron.
150 times.
150
the
times.
Wavelength.
At the point of collision, it will be somewhere along that length, right? This particle.
But it actually is at the electron. The point of impact, it's sort of what's called wave collapse. It actually becomes it actually hits it on the electron itself, and it's sort of you can think of it shrinking into a point particle.
So basically, if we're gonna visualize this, you want us to basically imagine a particle which is shaped like a wave that's 150 times the size of the electron.
Yeah.
But is the electron
absolutely
ridiculous? Is there any
Can I try a better analogy?
This is why it took until 1927 to work this stuff out with very clever people. It's complicated.
Or maybe it's just wrong.
No, it's not. All the tests and all the experiments we've ever done confirm the model I've just described.
Or it's just a description. That's all it is.
If you could find an experiment that invalidated what I just said, you would be getting the biggest
very, very smart
you could have.
What's the experiment that does validate
This electron, does it have like a magnetic field? Is it does
well, it has magnetic moments.
Okay, cool.
They don't have a magnetic field.
The massless particle wave can bump into that magnetic field.
It's not
energy?
magnetic; it has a magnetic moment.
A moment of magnetic.
Well, actually, I'm sorry, I'm saying that. Actually, I think you might be able to regard that as. In fact, that's where magnetism comes from. When all the electrons align, the spin of all the electrons align to make it magnetic. So actually, you might be right. I think the magnetic moment that I'm talking about, you can actually regard as being the source of magnetism. Carry on.
Okay. That was just a question.
Could I ask Rumpus a question?
Go ahead.
Rumpus, you know radiative heat?
Yes.
Will that travel through a vacuum indefinitely?
Yes.
That's what we were talking about to begin with.
Yeah, I know.
We could go back to the original
Yeah,
thing.
I know. Yeah, I know. Right. So
just like radio waves, so it's no different to radio waves, and you can see through a vacuum. If you put an object inside a vacuum chamber, you can still see it because the light rays pass through the vacuum and then through a window that you're presumably looking into the chamber in and hit your eyes. So yes, they do go through a vacuum, no problem.
You know, it's funny, Rumpus, because radio waves don't travel through plasma.
So
They don't do that. Like fire, like forest fires and shit. Radio
Yeah, of course.
waves
It doesn't travel through plasma, correct? Yes. So what? We're talking about a vacuum.
Okay.
Yeah. So yeah, but this is about the heliocentric model. How come then on the globe Earth, within the heliocentric model, how come it's only the radiative effects of the sun that is felt, and not the radiative effects of, let's say, Polaris or every other supposed massive sun that's out there?
Because the energy from the sun is a factor of trillions times more powerful than the power from Polaris. I mean, what don't you understand about something being closer in the inverse square law? If something's 400 light years away, like Polaris, the inverse square law says that the power from it would be next to zero. Where you've got something, the sun, right next to us, the inverse square law says it'd be much bigger. What's the problem with that?
I know about the inverse square law, but but the problem is that doesn't. You said radiative heat will travel indefinitely through a vacuum. You agreed to that.
Yeah, but there's still the inverse square law, so it goes by the distance. So they're saying that all the stars are negligible.
But
If you
sure,
collect power from them.
you understand what I mean?
Unit
But that's
area
a contradiction.
is inversely proportional to the square of the distance. So the distance is absolutely unbelievably huge to Polaris. Therefore, the power per unit area received from it is absolutely tiny.
Yeah, but you're missing the point.
I'm not.
You're saying that radiative heat will move through a vacuum indefinitely.
Yeah.
So if radiative heat will move through a vacuum indefinitely, then we should definitely, if we were on a globe out in the middle of a vast space with not much stars all around us, regardless of the distance, if it's moving indefinitely, then we should have a lot more effects than just the radiative effects.
No, not necessarily. Go ahead, Rob.
No, you go ahead. You can answer him.
I was just going to say...
No, I know about the inverse square law.
Well, if you know about the inverse square law, then you know the answer. The intensity is 1 over the square of the distance. The distance is absolutely enormous. Therefore, the intensity of Polaris and the heat delivered is absolutely tiny.
Then, in that case, what you're saying is the radiative heat dissipates.
Yes.
How does it dissipate in a vacuum?
Because it's the area. It's got you think of it as a sphere. Like I've drawn it here on the screen here. You can think of his Polaris as the sun here. So the power, you can think of all the power being radiated by the surface of the sun. And look, out here, it's the same power has got to fit in this same surface. And you can see, therefore, the power is going to be the 1 square of the distance over that. So if this is let's suppose that the sun here is this scale model here. Let's suppose the distance here is 10 times to we won't call this the Earth. These are 2 bodies that are radiating. We've got a radiative body in the middle, and we've got a body out here, the blue one that I've got labeled Earth, but we pretend it's not Earth, is 10 times as far away as the surface of this object. Therefore, there'll be the power per unit surface will be 1/100th of the power that's at the surface of this thing. And if you multiply that by light years, in other words, this circle is, on this scale on my drawing is the size of the Earth, then the power per unit area, the power on a particular segment of this line will be trillionths of what it is at
You're
the sun.
overcomplicating it.
Well, but hang on.
Brian,
hang on.
Yeah, I think so.
All you need to know, Brian, is that... Hold on, let me just say...
I understand the
Go
inverse
ahead.
square law. The point I'm making is the globe Earth is
spread over a bigger surface, effectively.
Let him finish, Rob.
The same power is spread over a bigger surface.
Okay,
I understand. The globe Earth is claimed to be millions upon millions of years old, and there's stars out there in the heliocentric model that absolutely make the sun into a dot within that model. Now, over that time, you would think that with all these other stars out there, with all this other radiative heat, there would be some other radiative heat buildup.
So, Brian, the answer is the Earth is radiating its heat as well.
Exactly.
So this negligible amount of heat or power from all these super distant stars, or whatever they claim,
It's tiny.
is going to be negligible because you have. Hold up, let me finish. So you have the photons that are radiating, right? But they're spreading out in accordance with the distance, the inverse square law. So very, very few photons compared to what was at the start is going to actually hit Earth. And all that while Earth is radiating its heat, so it's not going to have any effect.
Correct. Well said. Yeah, that's exactly
right.
But
you're telling me again about the inverse square law.
About the plasma. I have a quick follow-up.
Yeah, so the Earth just radiates heat.
Well, can you say that?
Which is that radio waves
I know that.
cannot go through or bounce off plasma. And so, and you agreed, and we kind of all agree. We can search.
Well, they bounce. No, they can bounce off plasma. I think radio waves.
Yeah, but not coherently, not in a measurable factor, right?
Yeah, I think
they will. Yeah, they will.
Yeah, it does. I think radio waves bounce off plasma.
Okay, you might think that. Okay, hold on.
All right, radio waves bouncing off plasma. I think that's gonna be all for me tonight. It's 8:15 anyway. Oh shit. Let me read these super chats. Sorry I didn't get to it earlier. I thought there'd be a break in that conversation, but it just kept going. Silent Zero, now demonstrate that graph in reality. Damn, I wish I knew what you were talking about. Silent Zero, sorry about that. Thanks for the super chat. C4, I stand corrected. Face 1 is more boring, way more boring. Shoot. I should unmute and read that, shouldn't I? Oh, fuck it, I'm gonna unmute and read it.
Off the sun.
So you have to start
You
with
can't.
the radio side.
Firefighters cannot even communicate in a forest fire with radio, with walkie-talkie.
Correct, and the answer is that there are certain
and that's high
frequencies.
power. That's
I'm giving you an answer. I'm trying to give you an answer. There are certain frequencies which bounce off the sun, and there are others that don't. So you pick the frequencies which bounce off the sun to measure its distance from.
You mean bounce off plasma?
Right? Yeah, bounce off plasma. Yeah.
Which frequency bounces off a black body?
Yeah, but
the sun is not a perfect black body. The sun is not a perfect black body. There are some frequencies in which it is not a black body, and those are the frequencies you pick.
Real quick, Chill is still muted.
Hold on, don't let him get away with that.
Unmute him. Hey guys, I gotta end the show. It's 8:15. You guys can keep going in a minute, but I want to read a couple things because someone's mentioned in it. So sorry, it's 8:15 already. Silent Zero said, now demonstrate that graph in reality. I can't remember what he was talking about. It was a while ago. Anybody remember a graph that we were looking at?
Absolutely no clue.
I don't either. Sorry, Silent Zero. C4, I stand corrected. Face 1 is way more boring. Ouch. Elabaka, is this the time of the show when quantum mechanics is denied by people using computers and phones? I mean, come on. So, thank you guys.
Right.
Appreciate the super chats. Thanks to the panel for being on the show. You guys can go back.
Answer this question.
Yeah,
Brandon.
wow.
I'm trying to do this question for percent for the last, I don't know, half an hour.
Oh,
now.
fuck, man. I'm only trying to host a
we'll
show
get in
here.
the after show.
Shit. Fuck,
all
man.
right, okay.
All right.
Okay.
Let me finish. I was just going to thank you guys for being on the fucking panel. And then
I was just
down.
wondering if I was going to have a 2-minute extension, that was all.
Oh, you want to do it on air?
Your final thoughts.
Right.
Why don't we just finish off with final thoughts there, and then that closes it up?
It was well over a minute. He couldn't have kept it. Sorry.
Go ahead and finish, Rumpus, if you're going to.
Okay, so quick. I'll try to do it quickly. So I've got Percent was trying to do this calculation about using the power of the Earth, of the sunlight, and therefore what is the power being delivered out the surface of the sun. So the way you do it is here you have the radius of the sun. It's 695,500 kilometers in radius. The Earth is 150 million kilometers away. Therefore, the power of the sun is at 1.4 kilowatts per square meter on the Earth. Therefore, you do this modifier to it. You just simply take the distance of the two, square it because it's following the inverse square law. That gives you this as the power of the sun per square meter. If you then multiply by the area of the sun, you then end up with this calculation, and then that calculation, I've just checked it, is the one they give on the power for the sun on the Wikipedia page. So in fact, the calculation does work perfectly, and I think it ends up with being something like times 10 to the 26, and that's what it does in watts per square meter.
Well, why do you divide by the radius?
Right. So the rate. So in other words, just like I was talking with James, the power of the sun per unit area here is going to be the ratio squared of the distance from the outside of the sun to the position on the Earth. So that formula there. So there's the power, 1.4 kilowatts per square meter on the Earth, and so I multiply it by this factor, which is the ratio of the radii.
You said it was 1.4 kilowatts per square mile.
No, you misunderstood. I kept on trying to correct you. I said square meter. For some reason, you decided to. No, I did not. I've never used the word mile. And I corrected you on that one. I corrected you when you said that on one occasion.
Okay. There's no way that they're going to be done anytime soon. Anyway, thank you guys. Thanks to the mods out in the chat. Appreciate it. Thanks to everybody who supported the show tonight. Really appreciate it. And we'll see you guys tomorrow night. Got to think of a topic that doesn't turn into a discussion about things that we can't verify. Now, if anybody has any topic ideas, hit me up on Discord. Otherwise, I'll come up with something. All right, we'll talk to you guys later. Have a good night. Bye.